people have also worked a lot in the past. The topic of my talk today is zinc refining waste in concrete. You have already known about my profile. I work on concrete technology and road safety projects also, because I have some exposure of working in field on highway projects earlier. Particularly, I appreciate this idea of AICTE to facilitate ATAL FDPs online, which are very useful in this difficult times, and they are facilitating connection pan-India without any constraint of movement and physical presence, which is very, very successful, I believe. Earlier FDPs have not been able to connect people who had some constraint of traveling and taking out time from their busy schedules, but this has become so much easy for everyone to attend. So before I start my talk, let me give a brief introduction of the topics which I will present. Is a little bit about the zinc refining waste, which are available in Rajasthan, and Professor Agarwal has already briefed you that Rajasthan is the largest producer of zinc in India, and it has largest amount of zinc mines and zinc waste simultaneously. The challenges of using these wastes in concrete. I will also talk about particularly ISF slag and specifically as a replacement of sand in concrete. The properties of concrete prepared by ISF slag using as sand in fresh state and also in hardened state. I will cover all the mechanical properties and comprehensively all the durability properties also. Finally, with some concluding remarks. Yeah, and then before we start talking about ISF slag and zinc refining wastes, we all understand that there are some essentials which concrete is expected to have. Whenever a designer designs concrete, there are few parameters on which the concrete should stand by and should be evaluated and come up perfectly as per expectations. So there are essentials and there are some expectations also. If we talk about essentials, then everyone will the first answer will be strength, because strength has been always associated with the quality that is checked first. So strength was always there. And if we talk about earlier days, like before 2000, then strength was the only parameter which was taken care of. And we researchers, I agree that we researchers knew that durability is paramount. Strength cannot ensure durability, neither durability can ensure that the strength will be as per desired, whatever has been designed by the designer. However, we all know by now, because it has been repeatedly said and repeatedly discussed, that strength was the only criteria of evaluating concrete in earlier days. Later on, it was realized that even a high strength concrete was not able to suffice the durability performance which were laid down. And it was also realized that there should be certain durability parameters also which should be linked with design. Whenever we design a concrete, there should be some criteria for performance evaluation also, on which I would say that the Indian standards are right now working. So strength and durability both, today we are considering both the parameters whenever we design our concrete. One more criteria that has been come up as per expectations. So strength and durability being the essentials, expectations are today that we also address sustainability. Sustainability is not new to all of us, because most of the participants, and I am also associated with research, so we all know that there are sustainability issues which we are talking about since 2 decades. And if we talk about global scenario, then sustainability was realized much earlier. Very interesting paper I had come across. The use of blast furnace slag as aggregate, as coarse aggregate, was started way back in 1912. There is a research paper from 1912 which reports a study, both application in field and also experimental analysis in lab. So sustainability was always realized, and now it has become a necessity. So I would rather say that it is expected. It is expected. However, now it has come as an essential. So both essential and expectations have to be fulfilled, and we have to consider both today. In today's scenario, this is more essential because there are legislative restrictions also. It is not only that there is a scarcity of raw materials. The another problem is there are legislative restrictions, and what I mean to say by legislative restrictions is that sand, construction sand, has been banned in Jaipur, not only in Rajasthan, but many states. And now and then there is some restriction on excavation of sand from river. So because of that, there is some deficiency, and for to cover up that deficiency and to make that natural material available for future generations, we have to look for sustainable solutions. So what is today's requirement is something like this. Let us see, just a minute. We all researchers want to address sustainability of concrete. However, durability of concrete from technical point of view is our prime concern. So the prime concern is durability, because if we are able to sustain, and if we are able to find alternative materials which are sustainable, and we do not create a durable concrete, then it is of no use. We will finally land up demolishing our buildings and creating new construction work every time. So the challenge which we should address is durability of sustainable concrete. It is not only important to design a sustainable concrete, it is very, very essential to check the durability and to propose a solution which is feasible, which is workable, and which can be adopted at construction sites. This, why am I talking about this, is most of the studies which are being reported and most of the discussions have drawn this conclusion that we cannot try everything and anything in concrete. The durability of concrete should not be compromised. At the same time, the solution which we are proposing to address sustainability should be feasible. It should not happen that a particular waste material is available in an industry, takes transportation cost also, and it will also be dependent on the availability of that waste material. For example, there are industries which are generating waste of X and Y ton. However, in construction industry, the requirement of raw material is huge, enormous. So the sustainable solutions should also be workable. And what I personally focus is on workable solutions. So this is the area of our concern. We have to establish durability of sustainable concrete. So if we categorize, particularly I have worked out this categorization of different kinds of wastes available in industry, or whatever is the type of waste that we have used in concrete. There are studies which have used agricultural waste. So agricultural waste, the most common agricultural waste is rice husk ash, which has been widely used as a binder. There are another bio-based materials also. Few bio-based fibers have been prepared, and there are many other kinds of waste which have been derived from agricultural uh, domain. The next categorization, if we categorize industrial wastes, there are many kinds of industrial wastes, and I would say that most of the concrete researchers have used every kind of waste. We concrete researchers are so passionate that we have been very passionately addressing sustainability and the feasibility of all materials. So the most popular industrial waste is fly ash, which has been now accepted, well used. Earlier in 1980s and early 90s also, when I was a student, I could see huge heaps like mountains of fly ash lying in the vicinity of thermal power plants. But nowadays you will not find such heaps. And then now you have to buy fly ash. And still the use of fly ash has not been fully utilized. So I would say that there's still scope to improvise design on fly ash and use of fly ash. The another kind of waste which we can group is as all used items, all kinds of used or worn out items. For example, there is tire, glass waste, many of the electronic waste, e-waste. All kinds of e-waste have been tried to be used in concrete as one or the other kind of alternative material for concrete. Another group, this mining and refining waste. I have categorized mining and refining waste separately other than industrial waste. However, it is known as industrial waste only. It includes all kinds of waste which are byproducts of refining processes, and also dressing of stones, and also mining of all these materials, metallic and non-metallic materials. However, the reason to keep it separate is this kind of waste is available in huge quantum. The amount of mining and refining waste is far more than all kinds of industrial wastes that are generated, and including chemical sludges, all paper pulp and sugarcane bagasse, everything is being used in concrete, which are industrial waste, but the quantum of those wastes is less. And frankly, it is better to invest time and energy in a material which is, number one, significantly beneficial for concrete, or which is available in huge quantities to suffice the requirement which we have. So mining and refining waste will include all kinds of metallic and non-metallic wastes which are generated during mining, dressing, processing, refining. Metallurgical slags also come under this kind of waste, and it has been tested from ancient times. The most popular waste is blast furnace slag, which has been used as aggregate also, and in ground form, it has been used as cementitious material, and we also have a blast furnace slag cement, which is manufactured. Okay, so after we have discussed this, I will straight away come to the topic of my talk today, which is zinc refining waste. So let us see the present scenario, mines, and the status of Rajasthan. Rajasthan is the largest state of India. So the largest state of India, of the country, has also the largest reserves of zinc mines. It is largest in India and second largest in the world. So you can imagine the quantum of production of zinc, and also the quantum of waste that is associated with this industry. HZL, Hindustan Zinc Limited, is the brand, is the company which has all lead and zinc mines, and it has 4 refining plants in Rajasthan. Approximately 17.7 million tons of ore is mined only for zinc, and out of that 1.2 million tons of metal is refined by Hindustan Zinc Limited per annum. And this they are expecting to expand the refining process with a new plant which is coming up recently. In one year I think it will be ready, and they will then escalate this production to 1.35 million tons. So that is obviously every industry will grow, and so on it will also generate more quantity of waste. And for our community, the researchers community, it will again give us a challenge to address that. The problem, let me come to the problem with this industry, is these waste landfills. What the waste landfills that Hindustan Zinc Limited has is, these landfills are spread over 75 hectares of area. So just realize that how much the huge amount of air land has been occupied just for dumping the waste, with more than 2 million tons of waste already stockpiled. They have different kinds of waste. So I have accumulated all the quantities, all the kinds of waste, and approximately 2 million tons of waste is already there in stockpile without no use. The disposal cost, of this waste annually is rupees 51 crores, which is a huge amount. And if we are able to address this problem, the industry will be also very happy to have solutions to this waste. The problem is, and why they are investing so much, the huge amount, because these waste landfills are secure landfills, because zinc is a heavy metal, lead is a heavy metal, zinc and lead both are refined, and the traces are present in waste. The waste is categorized as hazardous and it is toxic in nature. So that is the prime problem. Okay, now this is the problem of zinc industry. Let me come to the construction industry. Let us see what construction industry has at present. The sustainability issues, although sustainability of every material is paramount, it is required. I will specifically talk about construction sand. Construction sand, let us see the scenario. Approximately 500 tons of natural sand is annually consumed for preparing concrete and mortar. This is the quantity for India only. And this quantity, which I have been able to gather information from sources, this quantity pertains to only concrete and mortar. This does not include road projects and embankments and backfill projects where we use sand for other purpose also. So 500 million tons is a huge consumption and a huge quantity if we want an alternative to be looked on. In Rajasthan, sand was banned. Use of natural sand was banned since November 2017, and the Supreme Court has not given any relaxation. So in Rajasthan, natural river sand is not available. But however, I would say that every one of you might be seeing natural sand here and there in projects in your vicinity also. The alternative material legally is crushed stone, and illegally there are many sources from where you will get natural sand. The cost of natural sand before this ban was about 800 rupees 800 per metric ton. Now it has increased to 1700 or 2000 rupees. The cost This cost is for illegal or black marketing available sand which is available through illegal manner. The problem is not limited to only illegal availability of sand through illegal means. Number of crimes in state. Every day in newspaper, you might be seeing news related to illegal sand mining. There are murders, there is black marketing, there are attacks, physical attacks on police team and also on the mining officials which are there. And to top on to top, this has also increased corruption. The problem can be understood by the number of criminal cases reported in a single district of Jaipur, more than 500 criminal cases and fine of more than 31 crores has been already reported from November 2017 to February 25, 2020. So this is uh, this is a alarming situation when we don't have any time to address sustainability. We have to come up with solution, and there will be more and more benefits of solutions, and whatever we researchers are doing, if it can be practically implemented on field, then there is, I think, then there is no looking back and the problem will be addressed. So when we say that we can use mining waste in sand, I have discussed both the problems of the mining industry and problems of the construction industry. And when we propose that the utilization of mining waste as sand and concrete, then the problem of both the industries can be solved. The broader advantages are solution to all environmental issues that the waste is causing, the saving of land, which is dedicated for dumping the waste, solution to all illegal activities, sand mining, and all related crime. Now, let me put forward that this problem is not only limited to Rajasthan. Illegal sand mining, the problem is spread across India. There are 12 states which have been identified as hotspots for illegal sand mining, which includes states like Rajasthan, Madhya Pradesh, also Maharashtra, Karnataka, Tamil Nadu, Kerala, right from and also West Bengal, Meghalaya. So there are 12 states which have been identified as hotspots for illegal sand mining. The advantages which I was discussing, I'll continue. So this kind of solution, when we propose that mining waste can be used in concrete, it will automatically give a sustainable solution for natural sand, because the mining industry is generating huge quantum of these wastes. So the prime benefit would be that there will be bulk utilization of waste. Maybe if we start utilizing the waste locally, then it will be consumed very rapidly and it will be consumed, and all these environmental problems can be solved. However, when we see the advantages, the picture is very rosy. But when it comes to implementation, then we realize that there are certain challenges. Challenge number one, quality assurance. How do we ensure that this kind of waste is will suffice our quality of concrete? How do we ensure the quality? There is deficiency of standards on particular waste, and sometimes the quality of waste of one lot may vary from the other. This is particularly not for the zinc mining waste, because all zinc mining waste is produced in a very controlled and quality uh, with a quality check. The why I'm saying this is that our concern is not the quality of waste. The industry is very much concerned about the quality of metal that they are extracting. So the process is controlled, and every lot of waste has similar kind of quality. So this, to some extent, we can ensure when we are using a waste from an industry which is working under controlled conditions. However, we cannot ensure this for all kinds of waste. So the biggest challenge is to ensure the quality of that waste. Another challenge is what should be the allowable replacement level, because we cannot depend on one study. Every research may be conducted in different environment with different parameters, and there may be difference of opinion in researchers. So which arises this problem that how do we generalize the results and how do we come up to an allowable replacement level? This has to be addressed. Another challenge, limited expertise. So I have used zinc mining waste. Someone else might have used some other waste. And I am particularly expert in this area. However, I may not be able to go on every site where this waste will be used. So there will always be limited expertise when we talk about different kinds of waste. There are so many variety of waste. So limited expertise is a biggest limitation of implementation of these kinds of industrial wastes on projects, on its practical application gets a limitation. Another and the most affecting challenge is acceptance and use. You all must be knowing this, that fly ash was known to have beneficial effects in concrete. Since 1950s, it was established. However, it took so many years to accept that practically on site and practically in field. It could not happen until it was enforced. After 2000, it was enforced that all the projects should use PPC only. When OPC was banned, practically when the availability of ordinary Portland cement was banned, then and only then people and public started purchasing PPC because OPC was not available. So such a hurdle, when everything has been established, then the biggest hurdle is the acceptance of that kind of waste. So keeping all these parameters in mind, the rosy picture which has all advantages and the challenges and practical limitations on field, I will present the study further. Yeah, these are two kinds of wastes which we have already used in concrete. The first one, this is ISF slag, Imperial Smelting Furnace slag. This looks very similar to sand. ISF slag is produced during pyrometallurgical refining of zinc and lead. Approximately 80,000 tons is produced in Chanderia plant in Rajasthan. This slag contains heavy metals, and that is why it is known it is not safe for dumping for a longer period on land. It is dumped in a secured landfill. However, it is not categorized as hazardous. It is not hazardous, but it has certain limit of heavy metals. Another waste is xerosite. Xerosite is a very fine powder kind of waste. It is produced during hydrometallurgical refining of zinc and lead. Approximately 49,000 tons is produced annually in Debari zinc smelter. This waste contains heavy metals, and this has also been identified as hazardous waste. during this talk, I will only present ISF slag because it will take discussion about zero site maybe sometime later. I have worked on ISO slag, and my colleague Dr. Priyansha Mehra has worked on zero site use of zero site in concrete. The gradation of ISF slag. So ISF slag, as I said, resembles very close to sand, natural sand. This is the picture of natural sand, and you can see visual visually there is no difference except for color. However, when we conduct the gradation or particle size analysis, then there is slight difference in few of the sieves, and we can say that ISF slag conforms to zone 1. It is more coarser, and particularly the difference lies here. The sieve, this sieve is 600 micron sieve, that is 0.6 mm. Natural sand has a portion of more than 60%. However, ISF slag has less than 40% material passing the 0.6 mm sieve, which clearly says that ISF slag is more coarser. However, there is no problem. We can deal with it because this matches very closely with natural sand, and also its confirmation as zone 1 sand has enabled us to use this ISO slag in as received form. So the biggest advantage with ISO slag is that you can use it in as received form. There is no kind of processing used, and there is no requirement of sieving this. You can just procure ISO slag and use it as sand. These are few of the important physical properties. The specific gravity is higher than natural sand, obviously, because it has heavy metals. Another point is the water absorption. It is very close to natural sand. So most of the properties comply with the natural sand. Morphology is very, very different. This picture is very interesting. You can see there are needle-like eruptions or spherical surface is there in ice of slag, and the reason is because it is quenched. The slag comes from furnace at high temperature, it is molten at that time, and it is rapidly quenched in water, and that is why this irregular kind of structure is formed and fragmented particles are formed. This particular SEM image is of slag particles which are passing 2.36 mm and retained on 600 micron. Another picture on the right hand side, this shows that the slag surface has cavities. So why is it very important to study the morphology? Is because in concrete, the particle shape and particle size has a very great influence. Another same picture. This I have studied it for slag particles which are less than 600 micron size. This one shows you the particles which are retained on 300 micron, and on the right hand side these are the particles which are retained on 150 micron. So what we can see clearly is as the size reduces, the irregularity in the surface reduces, and these surfaces are more resembling like sand. However, the surface is rough. Natural sand is weathered rock, and therefore the surface is very smooth. Here, if we talk about the particles which are less than 300 micron, we can see few spherical particles also which are beneficial for concrete. These are the pictures of natural sand, and as I said, natural sand has all weathered surfaces which are smooth, and this will be the difference between ice of slag and natural sand. Next, coming to the mix, we had studied two kinds of mixes, one with a higher aggregate cement ratio and one with a lower aggregate cement ratio. In a higher aggregate cement ratio, we had studied further four kinds of water cement ratios, and in lower aggregate cement ratio, three kinds of water cement ratios were studied. Sand was replaced with isoslag from 0 to 70% in increments of 10%. And why we had limited it to 70%, we did not go to 100%, because after 70%, it was very difficult to prepare concrete mix. Practically, it was so concrete beyond 70% replacement showed the deficiency of paste, and the reason for this is lack of fines. You can see here that the 150 micron sieve had at least 5% of finer material. However, here with ISO slag, it is marginal. It is only 1% or so. So if there are less number of fines is there and you are not compensating it with another material, then it becomes difficult to prepare mixes with a replacement higher than 70%. So we had studied all the concrete mixes up to 70% replacement. Now let me also mention you the replacement was volumetric, and the reason was that specific gravity was different. So ideally, technically, we should replace a material with volumetric, equivalent volumetric replacement should be made in such a case. These are the elemental XRF analysis of all the mixes. For ease, I have picked up only control and the 70% concrete mixes over here. Otherwise, the data would have gone to 4 or 5 slides. Total number of mixes were 56. Ice of slag, as you can see, there is percentage of lead and zinc. However, when we see the concrete mixes XRF, we don't find appreciable amount of lead and zinc, which was expected, and this was promising also. The other water cement ratio mixes also showed a similar kind of XRF oxide analysis. The percentage of lead and zinc was very marginal, which is also attributed to the presence of lead and zinc in cement. Cement also has very trace amounts of all metals. Now, I'll start discussion about all the properties of concrete one by one. The workability, I'm not showing the results of workability because largely we had controlled workability. The reason is that we have to keep one parameter changing so that we can compare all the mixes. Therefore, workability we had controlled and we had maintained it uniform by adding super plasticizer. The reason was that with addition of iso slag, the workability was observed to decrease. So to maintain workability of each of the mix, we had added sufficient quantity of plasticizer that was PC based third generation plasticizer to the mixes. The density of mix slightly increased because the specific gravity of iso slag was high. And one more very interesting observation of fresh concrete that I would like to share is there was no kind of delay in setting and hardening of concrete when we had added 70% of ice of slag also. And I did not mention the background, the studies, the previous studies on ice of slag. There are many studies which have reported that any kind of zinc or lead waste, when we add that to concrete and within a cement matrix, it delays setting. So this was a biggest concern for us when we started this work, that if iso slag addition delays setting and hardening, and if it affects hydration, then we cannot recommend the use of ISF slag. However, we did not find any kind of delay, and there was no problems in setting and hardening. The reason for this observation and the reason for delay in setting and hardening, which earlier researchers had reported, the reason is that earlier researchers, when they used ISF slag or when they used zinc, and they had also doped cement with zinc, all those studies had mentioned the experimental results of um hydration reaction with ground kind of waste. The waste which was in powdered form, which means that the effect of the waste would have increased in terms of hydration. The waste would have participated in hydration, and when it is accessible, when you allow zinc or lead or any kind of heavy metal to react with cement, there is some delay in hydration. However, ISF slag, being amorphous, being granular, did not participate in hydration, and that is why we did not witness any kind of delay in setting and hardening. And this is the reason which ensures that ISF slag can be used as sand. It is preferable that it should be used as sand, not in ground state as a binder. Coming to the mechanical properties of ISF slag, these are all 56 mixes. If we start from the lowest strength mix, then this mix is having a water cement ratio of 0.55. Here is the legend. And we can see that most of the mixes have similar to control. Control is the 0% mix, similar to control or higher than control compressive strength, except for the mix which has ISF slag up to 70%. The 28-day strength is more stabilized. There are less ups and downs. So the strength of control mix has also been achieved. In 7-day compressive strength, there was appreciable difference. For example, if we consider this mix 0.50 water cement ratio, it has higher than control strength in all of the specimens. However, when we see the same mix in 28 days, the line is more straight. So the reason is that at 7 days, the compressive strength of ISF slag mixes was appreciably rapid. No, this would be a wrong reason, because ISF slag is doing nothing in hydration. The reason goes back to the morphology. As I have already discussed, that the morphology of ISF slag was irregular, and the particle size, the particle range, maximum particles were falling between 2.36 mm to 0.6 mm. Maximum particle size were of that range, and that range particles had irregularities in their surface. There were cavities, and it it is obvious that some of the water would have been entrapped in those cavities, and this has resulted in lowering the effective water cement ratio. And that is why we have achieved, we are seeing a superficial growth in strength in earlier days, which stabilizes gradually. The 90-day strength, compressive strength, is also similar. It is now more clear that the difference between ISF slag concrete mixes and those of the control mixes is very marginal. So from compressive strength point of view, what we can say, we can clearly say that up to 70% also we can use, except for this mix, which is at the highest water cement ratio. This is showing a little bit dip in the compressive strength. Otherwise, all of the maximum mixes are showing, as compared to control, there may be high appreciable increase in compressive strength, but what we are concerned is how much decrease we are observing. So the decrement is marginal, and which supports the use up to 70%. We had also examined the flexural strength. In flexural strength specimens, this was very clear that up to 60% only we are getting strength, which is as compared to control specimen. And all of the specimen having 70% ISF slag were having a significant decrease in flexural strength. The reason could be clearly attributed to lack of paste in 70% samples. Flexural strength is very much dependent on the paste quality, and the flexibility is attributed, the flexibility of mix is also attributed very closely related to the paste characteristics. Again, the pull-off strength, which denotes the strength of the cover zone concrete, also showed that the 70% ISF slag samples are having a decrease or a significant decrease in comparison to control. So largely we can say that compressive strength is okay, but the flexural and pull-off strength do not recommend use of ISF slag more than 60%. And if we are able to compensate and design a mix with proper paste content, then this deficiency can also be overcome. Now coming gradually moving towards other properties which are very much important for concrete to be applied in construction projects is abrasion resistance. The abrasion resistance of all these mixes, 56 mixes, is presented here. And largely we can see that there are few specimens which have abrasion of more than, or we can say the depth of wear was more than 2 mm. Now, why this line of threshold at 2 mm has been drawn is that as per IS 1237, there is one evaluation criteria that concrete having less than 2 mm wear can be used for preparing heavy duty floors or tiles used for heavy duty purposes. And if a concrete has concrete specimen is having abrasion or wear less than 3.5 mm, then it can be used for general purpose tile, or in factories also it can be used. In that sense, all of the concrete specimens can be used for general purpose tile, and particularly up to 50% replacement. This is 50, and all the concrete mixes which have ISF slag up to 50%, we can use the concrete for preparing heavy duty floors also. Now, interestingly, what I want you to see is the control mixes. All of the control mixes have the wear, average wear of less than 2 mm. So there was no problem in the concrete. The concrete was very much supporting the abrasion resistance, or the required abrasion resistance was found. But as we increase the slag content, we can see there is the abrasion resistance decreases. The reason could be that if we compare normal concrete, the conventional concrete, it has sufficient paste. And when we finish the surface of cubes, or when we vibrate the cube, or at site also when we apply vibration to column and beam, the paste comes over upside, and the surface is very much finished. However, in ISF slag concrete mixes, I had already stated that there was some deficiency of paste. Fine particles were missing. And that was the reason that the surface was not very smooth. And when we abrade, when we apply abrasion to a surface which is already not very plain and smooth, then the abrasion depth would be obviously more. So this property can also be adjusted or compensated by adding some fines. However, we did not do it because we wanted to test actual effect of isoslag. Now, very important property, other than this mechanical properties or durability of concrete, we have to check what is the effect of isoslag which has heavy metals, and are we using the are we using the isoslag which is dumped on landfills, and then we are using it in a sense to make a solution. However, we end up giving another problem. So leaching, what I mean to say is isoslag contains heavy metals, and that is why it is not advisable for zinc industries to dump it in open lands. And if we use it in concrete, and if we use it for water tanks, then would our water be contaminated? And if we demolish a building which has ISF slag, what will be the second life of that demolished concrete? What will be the effect if ISF slag is used as sand in preparing concrete pavements? Will the water get penetrated in this concrete and contaminate underground water table also, and there will be further damaging effects? So this was checked by evaluating and measuring the leaching potential of heavy metals. This you in pink, it is written the limits which are allowable. For lead, it is said that not more than 5 ppm is allowed, and for cadmium, not more than 1. Zinc has a higher limit because zinc has been given as a supplement also, so there was no problem with zinc. However, these two heavy metals were checked. For raw ice of slag, the leaching was quite large and it was not acceptable. The leaching of lead was 25 ppm, and that of cadmium was also higher than the allowed percentage. However, very interestingly, and this gave us promising results and encouraged us, that all of the slag mixes which had 70% isoslag, these mixes are all these mixes which have been tested for TCLP contained 70% isoslag, and all the limits show very encouraging result that it has been drastically reduced. So which means that yes, it gave us a green signal to go ahead and go further for the long-term testing. Long-term testing of all the concrete specimens were conducted for evaluating various parameters related to durability. First parameter is permeability. We all know that permeability is associated with transport of aggressive agents. If there is an environment which is harsh and our concrete is exposed to aggressive environment, most of the projects other than buildings are open to environment and open to sudden changes in environment and changes in moisture, changes in temperature, which affects concrete largely. In buildings, I would say that buildings are very much protected because the exterior wall is also having plastering. It is plastered. So the concrete and the structural member doesn't get contact with the environment. A direct exposure is not there. Now, when we say permeability, then we have to check air and water permeability both, and there are many methods. For permeability, all tests are indicative. I would say from here, because all these tests are indicative, so we can largely compare that, okay, this is the data for control specimen, and the other is for any constant variable. So we can compare and we can draw conclusions that would indicate durability. It will not ensure. So it is very essential, it is very important to closely observe all the test results. And one more point which I always mention to my students also, that you will get what you have prepared. You will get the results of concrete. In concrete, there will be no straight line. The results are very abrupt sometimes, and you have to bear with that. Don't get upset. Concrete is a material which will always give you the result and which will always show you what you have done. If you have done something wrong, it will give you the result. So there is nothing to be disheartened, and it is better to find what was the reason behind that. Okay, so let me again come back to the topic, air permeability. This was conducted using autoclam permeability index, which is more useful for knowing the permeability of cover zone concrete. The test results show that permeability of only 0.55 water cement ratio was more than zero point 0.1 and 0.50 water cement ratio. There were two water cement ratio, 0.55 and 0.50, which had permeability of more than 0.1. More than 0.1 we emphasize because it indicates low risk of durability, and all the specimen had a range between zero point 0.1 to 0.5, which indicates that the risk to permeability or the risk to durability is medium, which also means that the quality of concrete is good. So when we say the quality of concrete is good, so let me compare all control mixes. All control mixes are having good quality, particularly the low water cement ratio mixes. These mixes, two mixes, which have water cement ratio of 0.45 and 0.40 perform better. And obviously, it is also known that when we get better strength and better quality of concrete because the porosity is reduced. Another concrete series which we had performed, sorry, another test which we had performed for permeability was the water permeability of cover zone concrete. Again, autoclam permeability apparatus was used, and here also we can see the concrete specimens which have more than 0.45 water cement ratio, that is 0.50 water cement ratio and 0.55 water cement ratio. These both mixes, they had higher permeability. However, one more interesting point is that there is no difference, or there is only marginal difference between the control and the concrete which has highest replacement of 70%. There were few specimens which had higher than control. The green bars, if you see the green bars has, this specimen has more than control permeability. Okay, so we will discuss it later because I have one more parameter to discuss on permeability. The reasons I will discuss collectively. Another test which we had conducted to establish permeability was bin permeability. This is a destructive test. Earlier, both the two tests on air and water permeability were non-destructive tests, which are widely used at site, not in India, but abroad. It is a sophisticated method. This one is more widely 1048, and most of the laboratories also have DIN 1048. So when we test DIN 1048, then all the specimen we can see are more or less comparable to control. There is no appreciable increase in permeability. So, and if there is some plus and minus, that is a deviation is there, then the deviation was within 15%, which is not significant. We cannot consider it as significant. So largely when we conduct a harsh test, which is a destructive test, and this test, in this test we can visualize, we break the specimen and we visualize the depth of water penetration. So this test indicates that there is no difference in concrete, which has 70% replacement of slag, and with the control specimen. Now the reason why few samples of air permeability and the water permeability were higher than control, and it was not found in another permeability test which was destructive, which was more reliable. The reason could be the surface quality of cubes used for testing. Now I will again remind you what I have previously also stated, that as we increase the slag percentage, it is it affects the paste content, and the paste of concrete gets reduced. So the surface of the concrete cubes that have higher percentage of slag was not very well finished, which had pores, and that would obviously attribute to and result into higher permeability. Again, this is very true because autoclamp permeability apparatus, you have to also look on which kind of apparatus you are using. I would emphasize on, I also tell this to all my students, that don't go by the steps of test. You should understand why you are conducting this step. If you are weighing a sample and then you are putting that sample in water or in oven, then you have to understand the logic behind it. Don't follow the steps without understanding, and understand why this technique has been used. Maybe you can also invent your own testing method. So the machine which was used to evaluate the air and water permeability of cover zone was uh, autoclam, and it was highly dependent on the cover zone concrete only, which is limited to 25 to 50 mm. It was not uh, testing the concrete core. That is why we have seen some deviation in results of autoclam permeability apparatus, and that with the DIN apparatus. The another reason is lack of paste, and why the lack of paste was evident is the void content of sand and slag were different. We had tested the void content of pure sand and pure slag separately as per ASTM, and it was there was an appreciable difference. The void content of slag was 43%, however that of sand was 36%. So this was another reason. Overall, what we can conclude is that for permeability, if we go about all the three kinds of tests, then we can recommend 50% per replacements. However, if we can modify our mix to compensate this, then we can go for 70% replacement also. Another parameter that we had evaluated is drying shrinkage. Now, let me tell you that it is not directly related to durability, because under durability, we are more focused on the harsh exposure of weather and all those mechanisms that deteriorate concrete. Shrinkage does not deteriorate concrete. However, it helps in progress of deterioration very fast. Shrinkage is one more property which which is going to happen. Every element which has water, and when the water evaporates, it will shrink, and when it gets water, it will expand also. So concrete is also it comes under same purview, and it expands a bit when it gets water, and it shrinks when the water evaporates, then when the pore water is not there. Drying shrinkage was tested for 1 year period under controlled temperature and humidity. It is very important to maintain humidity and temperature control. Otherwise, in summers, you will experience a drastic shrinkage, and when there is a monsoon, you will again see that your specimens have expanded. So, shrinkage results largely, I will discuss it, the results in a tabular form. What you can observe here is largely the shrinkage strains are similar. There is not an appreciable difference is not there. However, there is few, you can see few lines here are different, but those mixes are different. These lines of dotted mixes, this is a mix of lower aggregate cement ratio. So this is an entirely different mix. In dotted lines, we can see some of the mixes have a very low shrinkage also. Similarly, other mixes. Now, in a tabular form, what I was saying that we will discuss and we can analyze, shrinkage is bound to happen, but we are more interested in the total strain. How much is the total strain and how much is the strain in initial days? It is very important to monitor shrinkage strain in initial days, because at that time, if concrete develops micro cracks, those cracks will be widened, or they will lead to more cracking inside concrete. So if we compare the shrinkage strain that was achieved at 7 day with the total strain after 1 year, then the interesting feature that we observed is that all the mixes which had isoslag had low shrinkage, lower than control. So the control specimen had achieved 37% of total strain at 7 days. However, the isoslag concrete had only 26% of total strain at 7 days. Likewise, all the mixes showed the similar result, except for the lowest water cement ratio mix, and it was largely same for the control and other mixes. The point here is, or the reason may be because of lower water cement ratio, the quality of concrete is better, the porosity is less, and the mix is dense, and therefore shrinkage is it is directly affected with the pore water. When you don't have more pore water inside, the shrinkage will also be less. Other mixes with lower water cement ratio and a lower aggregate cement ratio also showed similar trend, except for one mix, that is the 0.4 water cement ratio mix. Here the control specimen had developed lesser strain at 7 days in comparison to all other isoslag mixes. However, all the other mixes of this series, which had a lower aggregate cement ratio, showed that the control mix has appreciably higher shrinkage strain at 7 days in comparison to all isoslag concrete mixes. So this overall, what do we conclude from this is that as far as shrinkage strain is concerned, the dimensional stability of concrete is concerned, we can get very promising, very beneficial effect of adding ISF slag. Why am I saying this? Is that it is clearly evident that ISF slag, addition of ISF slag in larger quantities reduces shrinkage strain initially, and whatever is the shrinkage is very gradual. It is not sudden, it is not rapid, and which is very beneficial when we talk about creep. Now, another parameter which was tested is carbonation. The depth of carbonation was tested at 6 weeks and 1 week, 2 week, gradually up to 12 weeks. This is the results for 6 weeks, and I will not go into much detail, but what we can observe is the carbonation depth of all the specimen having isoslag is less than control, except for one mix which is at the highest water cement ratio mix. 70% isoslag results were higher than control. Otherwise, all other are very, very similar or less than control. Another water cement ratio mixes the depth of carbonation after 12 weeks. What we can observe is initially this mix at 6 weeks had higher than control. However, later on, the depth of carbonation in control mixes was higher, and all the specimen which had isoslag, the depth was witnessed to be less than or very, very similar to the control specimen. This again was very encouraging. And if we have a look on the lower water cement ratio mixes, you can see clearly that the depth has reduced. What I want to emphasize is that the results of ISS slag with relation to carbonation, shrinkage, and the durability evaluation are promising. So, to summarize, shrinkage and carbonation, I have already mentioned that both the properties supported use of isoslag up to 70%. Next property that we had studied is corrosion of steel reinforcement. Corrosion is culprit for deterioration of most of the RCC structures. It is known that corrosion is the biggest threat to buildings, and some of the countries have now started using stainless steel reinforcement also, which is of appreciable much higher cost than our mild steel and the reinforcement that we are using. So this is the specimen detail which we had used, and we had measured three kinds of observations to monitor corrosion. One was macro cell current, the other was half cell potential, and the third was the corrosion rate. Macro cell, now let me tell you the macro cell current and half cell potential. Both are performed on specimen by connecting anode and cathode. We get the macro cell current, and as per ASTM G109, this was conducted. You can see very abrupt changes in the current, which is normal because corrosion is electrochemical activity which is going on inside concrete. It measures that. So there is no worries to get such results when you are measuring corrosion. This is a chart of highest water cement ratio, and I have also only taken two kinds of water cement ratios, for example, for discussing here. Otherwise, the presentation would have not been able to sum up within the time. Largely, what we see is the change in current, and how do we indicate that the corrosion is going on? We take a positive macro cell current of more than 10 microampere to be indicative of active corrosion in progress. So the macro cell current of more than 10, wherever we witness that, this indicates that yes, corrosion is going on. Otherwise, under this concrete mix, we can see it is very difficult to see a high rise in macro cell current, and most of the time current is less than 10 microamperes. The another mixes for macro cell current also, there is no need to explain. These are the currents. And another test was half cell potential on the same specimen. by disconnecting the connection of anode and cathode and taking the potential difference with help of a copper sulfate half cell. This was recorded. The potential of all the anode less than minus 350 millivolt was considered to be an indication of active corrosion in progress. So we can see that in this particular mix, there is a sudden dip. There is a sudden dip at 18th month. The corrosion test was conducted for 2 years, and this was done by facilitating samples by alternate wetting and drying cycles of 2 weeks each. And there was in between also the current, the potential was higher than minus 350. There are, we can clearly see that after 5th month, or yes, after 4th month only, there are specimens which are showing more than minus 350 millivolts. These are other mixes. Finally, the corrosion rate was computed. And how do we compute the corrosion rate? Because earlier both the samples, or sorry, both the observations were based on measurement of current or potential. This was the final test when we broke the samples and we visually observed what is the condition of reinforcement. We found that there is corrosion, and the corrosion rate was computed. It was seen that most of the samples with higher water cement ratio had developed corrosion. However, the samples having lower water cement ratio, there was nil or very less corrosion. So this largely, if we compare the results, corrosion was not a problem at all. You can see that corrosion of slag samples having 70%, 70% slag also was very, very less than control, except for one which has been always deteriorating since all the test, in all the tests this was having same kind of results. So now I will sum up the results finally, which I have already discussed during each of the parameter also. This is the conclusion in a tabular form, and there are publications if you want to see. Now a very, very interesting study which I am currently doing. I will only it. This is artificial sand prepared from marble powder, waste marble powder. This is 100% waste marble powder, and we have granulated it, made it spherical in shape. And these are the properties of this sand. So if this gets successful, then I hope that we will get a solution to all mining problems in Rajasthan, because marble is also a very big problem for Rajasthan to tackle. And this is all from my side for today. I'm open for discussions, and this technique particularly is under patenting, so I'm not presenting more details. Thank you for your very patient listening, and I'm open for questions or discussion.
Thank you, madam. Participants may ask their queries. It seems participants have understood everything which you have explained nicely. So mainly the extensive research work, how it is done, is explained in this beautiful presentation. So many parameters investigated, and we are glad to know, madam, that your group is also working on waste marble powder and has applied for patent. This will be a great boon to the state of Rajasthan if the solution occurs. And so with this, I Thanks once again to Madam Tripathi ji and for sparing her time. I may share with you all that she is a corona warrior. Uh, she recovered from corona. Then also she spared about 75 minutes presentation. So I'm very much grateful to her. And uh, despite her recovery period, she managed it. Thank you very much, madam. Thank you.
Thank you, sir. Thank you.
If
It was
any
great to be here.
if any query of the participants is received, we will forward to you, madam.
Yeah, thank you, sir.
Now, it is my privilege to welcome Dr. S.B. Hegde, sir. He is domain expert of cements and concrete. And we welcomes you, Dr. Saab.
Thank you, thank you.
And he has been very kind. He has worked in R&D. He has been involved in product development in cement industry overseas as well as in India. In many firms, particularly he has worked in Europe and traveled extensively. And we are fortunate to have him here to share online and offline instrumental analysis methods for cement manufacturing plants for quality assurance. And I welcome him and request him to guide us. Kindly,
Thank you very
Dr.
much. Thank you very much, Dr. Agarwal, for nice words. Now I can present, right?
Yes, sir. I also welcome Dr. Narayanan also here. I'm from Reliance Industries.
Namaskar, sir. Namaskar, Shubhrabhat.
Suprabhat. Dr. Rajamane also joined, but somehow he has left in between. Everybody in country knows his name, N.P. Rajamane. He has left for some work.
So there is, Dr. Agarwal, please help me out.
Yes,
If I
please, sir.
click the present now, there will be 3 buttons. View
Yes,
entire
sir.
screen, window, and tab. Which one should I select?
Window, sir.
Window. Okay. Give me 1 second.
If you opened PPT on your system, laptop or desktop, then window option. If you are opening through net, then tab section. Tab.
Now what I will do, I will just open my presentation in the desktop.
Yes, sir. Then in window it will be seen, and then you may select it and then open it.
Yeah. Sure. So now is it visible now?
Yes, sir, it is coming, sir. It has come, sir.
Yeah. Is it okay now?
Yes, sir. PPT is visible, sir.
PPT is visible, but it is not visible to me.
It must be visible to you. Let me check if.
1 minute. I will stop presenting. I will do it once again back. Same thing. I will do it.
If it is not visible
now?
Yes, sir, it is coming to. It has come, sir.
It has come, right?
Yes, sir.
Okay. Thank you. Good morning to everybody. So I am going to talk something different subject. I think it is very much essential that should not become monotonous. So Professor Agarwal has suggested me to talk about some analysis online and offline for the cement manufacturing side and allied raw materials for quality assurance. So thank you very much, and let us see slide. So what I will do is for the sake of all the participants, I would like to start with a video so that about the manufacturing of cement, so that it will be very easy for me to talk about the online and offline analysis during my presentation. Is it okay now? Is it audible?
Yes, sir. Voice is not coming off the video.
It is not okay.
Video's voice is not coming.
Not coming.
Yes, sir. Any other participant may tell if the voice of video is coming?
Yeah, kindly let me know, because here it is coming.
No, sir, it is not coming, sir. It's not audible.
Audible?
No,
The
sir, it is
video
not
is
audible,
coming.
doctor. Video is visible, but audio is not audible.
Okay. So I cannot do anything, but just at least participants can see the video, right? So what I
Yes,
will
sir.
do,
Yes.
during
Yes, sir.
moving of this picture, I will give a short commentary so that there will not be any problem.
Sir,
So as it is being shown in this picture, the manufacturing consisting of the quarrying and in the limestone mine, which is being blasted, and the blasted material will be taken to the limestone crusher for size reduction. This is the bench of limestone mine. They have, and this will be dumped into the primary crusher for crushing of the limestone. And needless to say, while this is being blasted and it is being crushed, the limestone analysis will be analyzed online. So next you can see some of the belt which is coming out from the crusher outlet, and it will be transported to the cement plant for making a stockpile of limestone. So this material is being, online, being analyzed online, and quality assurance department will get the information of these materials on the real-time basis, whether to this composition of the limestone is as per the target or not. And this has been filed in a stockpile, and you can see that the limestone has been transported inside the raw mill, where different gradients of silica carriers, alumina, iron carriers will be dosed and ground in a mill called raw mill. So those powder, once it is crushed, is being stored in a silo. You can see the silo now. And while doing quality assurance, this will be analyzed every hour basis, and this material will be injected into a kiln where it is being fired at 1450 degrees centigrade. You can see the rotary kiln which is under operation. So inside this there will be 1450 degrees centigrade, and all these materials will be converted into a boulder type material is called clinker. This is the view of the burning zone inside the kiln. And this hot material will be sent to the cooler where it will be quenched from 1450 degrees centigrade to around 1000 degree or 800 degrees centigrade in a cooler. And that cooled material is called clinker, and which is being transported into a clinker silo where it will be stored, and it will be taken out from the silo and put it in a cement mill. You can see that the belt containing clinker and gypsum materials are inside the cement mill, where it will be ground and cement will be produced. This is, you can see some of the cement mill. So this is the gypsum they will add to produce OPC cement. So every time, every 1 hour, the ground material's fineness will be determined. as per the target, whether it is coming or not. And inside the mill, you can see these balls. These balls will be there and it will get bombarded to each other, the material of clinker and gypsum. And this forms a fine material called cement. And in this picture, what I have done is that you have now understood the broad way of manufacturing of cement. So for the sake of better understanding, nowadays cement technology has been progressed a lot. There have been a very sea change from 10-15 years from this side. There have been a revolutionary improvement in the cement technology. Earlier, you might be aware that the dry process was there. Sorry, wet process was there and semi-dry was there. Nowadays, everything has become dry process. In dry process itself, there have been, sea change. A lot of technical advancement have been taken place. You have seen that the limestone is being mined and being transported to cement plant. So I will show in the next slide, while it is being transported, the limestone composition, because we have to design a cement quality as per the market requirements. As you are aware that since you are all civil engineers, you know that what type of characteristics of cement should have. Generally, construction industry requirement is that you have to have a initial 1 day strength and fast setting, and so that it will increase the construction speed as well as the high strength, because you can save some of the cement component while designing the concrete mix designs. So accordingly, we have to design our cement quality also, taking view of our source of raw material, its composition, etc. You are aware that cement consists of 4 ingredients like tricalcium silicate, dicalcium silicate, tricalcium aluminate, and tetracalcium aluminoferrite. So depending on the requirement, we have to design the limestone composition also, the requirement of limestone quality to the mines, and mines will supply the limestone to the cement plant, and this limestone is being analyzed online. Nowadays, this limestone is being analyzed online on a real-time basis. So we are making a stockpile of limestone, say around 25,000 to 30,000 ton one pile, and that pile will be as per our target prepared based on the cross belt analyzer what we are going to show you, so the desired composition. And in this picture you can see a cement plant is there, and on the top of it you can see the calcium carbon dioxide and SO2 or SO3, whatever it is, because environmental parameters are so stringent nowadays that all these the analysis of the micro particles in the cement premises and during the process, and the different gases are being generated because of the firing of calcium carbonate, etc. The CO2, SO2, NOx, all these gases will be generated, and how much gases will be generated, that will be recorded online, and this online analysis is connected to a server of state pollution control board and central pollution control board, and this is a norm. And because it is a requirement also, if any cement plant is not giving the real-time data online analysis to the website of pollution control board, the pollution control board can have a power of stop the cement plant. So the environmental aspect has been very much imposed on cement industry for the CO2 and other particulate matters and different gases. So here in this picture you can see that these are all online analysis. You can see what is the CO2 is being generated, what is SO2 generated, how much is NOx is generated, and at the bottom you can see different compartments are there. So one is for the chemical analysis of raw meal, which is a semi-finished material. Raw meal is nothing but the mixture of limestone and clay and iron and silica material. So that is a raw meal, or which is a kiln feed. That means this powder is going inside the kiln for the burning process. So that is also being analyzed online. You can see first box. And second box, you can see that this is online loss on ignition basis, because you must be aware that 100% calcium carbonate is 56 CO is there. Okay. So if it is 100% calcium carbonate, the CO content will be 56 and the loss on ignition will be rest of the thing 44%. So depending upon the requirement of the kiln feed, we are monitoring in the system in the cement plant the online loss on ignition basis. That is, it will show second by second the analysis, and people will be there to observe it and whether it is in line with our requirement or not. And third one is the box is online free lime analyzer. The free lime is nothing but whatever lime which is residual lime left over after the reaction of lime with silica and alumina and iron, whatever leftover lime is called free lime, because free lime content is a very important for it decides the quality of cement. You must be aware that if calcium free lime is on the higher side, say more than 3% or 3.5% in the cement, which will cause expansion of the cement. And you can see in the plasters or in the concrete, you see the expansion and you see the so many cracks being developed because of the higher content of free lime. And also the another one is that the magnesia content. So this magnesia content and free lime content are responsible for to cause the unsoundness of cement. So you can see the second box which I have seen is that there will be XRF. I will show in the subsequent slide. The XRF will also the online analysis of raw meal, kiln feed, cement, clinker and cement. So for your understanding, the semi-finished material in cement plant terminology is that the kiln feed, raw meal, clinker are called semi-finished material, and finished material is nothing but cement. So fourth one is I mentioned the free lime analyzer, because we target around 1.5% or 1.6% free lime in the clinker while production. So fourth compartment you can see the box which is online free lime analyzer, and the another next box to this fifth box is online particle size analyzer. So this is nothing but when we are producing cement, the particle size distribution is very important. As you must be aware, we generally maintain the residue on 45 micron. When we are talking about the fineness of cement, we are giving a target to the plant on 45 micron residue basis, 90 micron or 45 micron residue. So, and there is also theory in the cement chemistry that the 3 to 32 micron particle sizes are very vital for the generation of cement in the system. So if anything, 3 to 32 micron particle size, if it is more than 60% is good. So 65% or 70%, so whatever higher percentage is there, it is considered as very good in view of development of cement strength in the cement. So here in the as per the technology and as per the online analysis, we can change the percentage. Some plants, if you see, it is very minimal. Some plants will 30 to 32 micron particle size will be 50% or 55%, which indicates that there is a lot of scope for improvement of the particle size distribution, so that they can get a better strength in their cement. So I will discuss still more detail while we are discussing about particle size distribution. And last one is that this is a XRD, X-ray diffraction, which I already means XRF means X-ray fluorescence. This is for determining the oxide composition of the the finished material and semi-finished material. And XRD is the analysis which we are talking about what is the mineralogy of the material. So mineralogy and XRF. XRF is a for oxide composition, to determine the oxide composition, and XRD is for understanding the mineralogy of the semi-finished and finished material. So nowadays, therefore, the control is very strict, because in cement industry it was not like olden days. Nowadays, lot of things are available. We are talking about alternate raw materials. We are talking about alternate fuels. We are also talking about secondary cementitious materials of different kind, apart from whatever fly ash or slag or metakaolinite or silica fume, etc. But there are also some new secondary cementitious materials are also we are using. So nowadays, the cement manufacturing is a very to check the cost, and according to the government imposition of environmental thing, so many stringent norms are there, and we are supposed to use alternate raw materials and alternate fuels. The pollution control board, while giving the consent to operate the plant, will take a the assurance from the cement manufacturers that we are going to use different wastes generating from different industries, so that and with that too without generation of much carbon dioxide, SOx and NOx. So stringent things are in place. So we need to analyze the samples more frequently. Therefore, these online analyzers have come to our rescue and helped our and as is helping us our life in the plant, so that whatever we are producing, it is as per the stringent norms or the requirement of us. So here in this picture you can see online limestone analyzer which I have shown. This online limestone analyzer is fixed on the belt. You have seen the belt which is carrying the limestone to the cement plant. After crushing of the limestone at the mines crusher, this will be placed. This equipment will be placed on the belt. Therefore, it is called cross belt analyzer, and which will give the chemical composition whatever is going across this stream of materials. So it's online. And second one nowadays has come as the coal analyzer, online coal analyzer, because coal is being used, as a fuel in the cement plant. Earlier, there was no online analyzer for coal. Coal will be collected manually and then being analyzed in the laboratory, which takes a very stringent process. It takes around 4 to 5 hours to check the quality of coal, because coal parameters are something different. You must be aware that some of the things like the volatile matter, calorific value, etc., which takes a lot of time. And similarly, the chemical composition of materials, we have to either do it by wet chemical analysis, or it is called gravimetric analysis. You might have seen in the laboratory, which takes around 4 to 5 hours to analyze manually. So in the cement plant, we are analyzing more than 400 samples in 24 hours of different in-process samples and finished material. So 400 samples analysis manually has been rolled out. It is not possible. Since the advent of so much of very advanced techniques, now cement plants are equipped with analyzing so many samples, even the raw material samples like bauxite, clay or silica or iron, etc., which is coming from, we have to buy all these materials as additives. That also being analyzed by X-ray fluorescence within no time. So if you consider the raw materials which are coming inside the plant for making raw meal or kiln feed. So we are analyzing more than 500 samples totally 500 samples in 24 hours time, and coal which is being received from the suppliers, and coal which is being used in the cement plant for burning process is more than around 60 samples per day. So this much of analysis is not possible manually. Therefore, the earlier cement plant operation was they were not analyzing so much of sample at all. But because of this analysis equipments, we are uh, we are able to do all the analysis and put the cement quality in check. And we are trying to achieve Six Sigma. You must be aware that the Six Sigma concept is very important. In cement plant is very difficult, but it is not impossible. So the quality conscious organizations of cement manufacturers are embracing this Six Sigma concept because of the very latest technology, state of the art plants, which may not be a difficult thing. But only thing is that when I say when we are, it is a general thing that when the technology is advanced and we are implementing such a advanced technology, means that we should have that technical know-how. We should be aware to take the full advantage, full potential usage of these equipments, latest technology to the fullest possible. And at the same time, there should be a backup required from the instrumentation side, from the instrumentation engineer side in the plant, because you must be aware that you may get because of the your financial affordability, you can get very latest equipments in your house also. But at the same time, we should be in a position to manage and maintain the thing. That much knowledge we should have, and how to use all these equipments to the fullest possible. That technical thing, know-how, we should be aware. Then only we can take the full advantage of the technology what we have been implemented or established in the plant site. Here in the picture, the first one is the online free lime analyzer. You can, when the clinker is being produced, you can see what is the free lime content. Suppose generally 1.5 to 1.6 is the target in the cement plant, whether it is coming or not. If it is coming less or it is coming high, so those things we have to take corrective actions. And here I would like to mention that there will be a pyro processing, which is very important aspect apart from quality assurance, that the 40 to 60% of the variable cost of cement manufacturing is coming from pyro processing. That means whatever the kiln feed we are burning along with the coal in the rotary kiln, we have to maintain around 40 to 50 parameters as per the requirement, so as to produce the consistent quality of clinker, stable kiln operation, and as per the desired capacity of the kiln. Then it will be all the parameters of this should be in the proper place. Then we can produce the cement or clinker with the desired cost what we are aiming for. If any haywire or undulation is there or fluctuation is there, needless to say, it will hamper the quality of the product as well as also the profitability of the plant. So here you can see some of these equipments I have shown on the right hand side of this. They are online gas analyzers, which I showed you, I mentioned now. SO2, NO2, CO2, CO, all these gases will be analyzed online. What is being produced are real-time analysis, and this is connected to the server of the Central Pollution Control Board and State Pollution Control Board. This is the requirement. And I mentioned about the particle size distribution of the cement, because as you are all civil engineers, you know the importance of particle size distribution and its importance about the strength development and other rheological properties of the concrete. So in the cement plant, As I mentioned earlier, we are targeting 3 to 32 micron particle size. Higher is the better. If it is coming 70%, it is better, excellent. If it is coming to 72%, is still more excellent. If it is coming less than 50%, which is a danger mark, we have to improve upon it. So there are controls available. With we have to change the the grinding circuit parameters in the grinding circuit. That means grinding circuit of cement grinding, the RPM speed or separator speed. So all these things is possible, and depending on that, we used to control the online particle size distribution. This analysis also will be on real-time basis. There will be offline also. There will be online also. So many of the latest technology cement plants are establishing this particle size analyzer online. Whatever cement is being produced from in the cement mill is going into the silo for storage. That will be analyzed and gives us the analysis of the particle size distribution. So to talk about cost, for example, this particle size distribution of cement on online analyzer is costing around 50 lakh rupees for one installation. That means one equipment is costing around 50 lakh rupees roughly. So suppose we have got 4 mills or 6 mills. So we will put one particle size analyzer in all the line. So it will be more than around 3 crore or something like that. So as I mentioned here, the X-ray fluorescence. This is used for finding out the oxide composition. What is the lime, CaO, SiO2, Al2O3, Fe2O3, and even some of sodium, potassium, any trace elements also will be analyzed in the X-ray fluorescence within 5 minutes. One sample will take not less than 5 minutes or 4 minutes. So if you are going by wet analysis in the conventional laboratory, it takes around 4 to 5 hours for one sample. And here you can see the first two are on the other top one side are bigger XRF, that is called WD XRF, and smaller one is there, that is a small portable XRF. This portable XRF, it has got its own limitations because it can analyze only 8 to 9 elements. Whereas here in the bigger XRF, you can analyze up to 14 elements, 14 different oxides, even including some trace elements. So needless to say that the cost will vary accordingly. Generally, bigger XRF will be there in the cement plant, in the integrated cement plant, and smaller XRF is there in the grinding stations. So here you can see the picture of X-ray diffractometer. It is not X-ray fluorescence; it is X-ray diffractometer, where the goniometer will circulate. We have to find out. We have to scan the material with the different 2 theta values, and then this is for the mineralogical analysis of the materials, whether it is powder material or semi-finished material or cement or clinker. So here we'll come to know about the mineralogy of the things, what are the mineral it is containing, and how much percentage it is there. For example, you know that C3S, C2S, C3S, C4AF. So if you take the clinker sample and analyze through this X-ray diffractometer, you will come to know what type of mineralogy it has got, because as you are aware that different polymorphic modifications of C2S, for example, or dicalcium silicate will be there. Is a lambda, gamma, all this beta, they are in different forms. So you will come to know by this analysis, they are in which form? They are in beta form, they are in gamma, they are in alpha. So it will determine what type of form it is and how much it is there. Even for example, we are targeting in the cement plant generally around 50% tricalcium silicate, because tricalcium silicate is a phase which gives the strength in the cement. So higher is the C3S content, higher is the initial strength and the latest strength. So this is, I'm talking about the general about these compositions. So by doing this Ritfield analysis, by using X-ray diffraction, you will come to know how much it is really there. How much real tricalcium silicate is there in the clinker or in the cement? How much dicalcium silicate is there in the cement? How much tricalcium silicate is there in the cement? So, and how much free lime is there in the cement? Everything you will come to know by this analysis. Otherwise, to find out that, we have to do microscopic analysis, which I will explain the time duration required, and it has got some shortcomings. What is that shortcomings and difficulty in that, we will discuss in the relevant section. So this is about the quant XRD and XLA fluorescence and XRD, to give you some get the feel of this. This type of XRD with all Ritfield analysis, and there is 50,000 phases have been stored in the system. 50,000 phases, inorganic phases and even organic phases have been stored in JCPDS files. And when you are analyzing the powder material through XRD, so it will try to match the 2 theta values of all these 50,000 phases which has been stored in JCPDS file, and then it will give you the probable minerals which are present in the system in your powder. So this is a very stringent analysis which hardly takes around, depending upon the scanning speed of your run. For example, it may end up, if I give 1 minute per degree, 2 theta degree, 2 theta for 1 minute. It may take to scan from 2 theta to 140 degree 2 theta, maybe around half an hour or 1 hour, like that, depending upon the steps which I have given you, speed I have given you, and set it in the system for scanning. So this will give entire spectrum of materials, mineralogy, and you can find out once the mineralogy name, if you identify, then it is very difficult for you to understand when it is formed, how much, what the temperature is required for the formation of these mineral assemblies, etc. All this you can interpret it, and you can do a very good study out of it. And next I have shown you is thermogravimetric analysis, is called also TGA. In this, TGA and DTA combined together is also being used to identify the mineralogy and to identify how different minerals are being transformed at different temperatures, depending upon the loss of weight and depending upon the prehydration characteristics of this, etc. can be used, and you can find out. Suppose if I want to use a different type of alumina clay and find out what is its heating pattern and how it will behave when you put it inside the kiln, because sometimes what happens is, when you are using this type of material, unless you know the behavior of these materials at different temperatures, how it will perform, how it will behave, etc., it will be very difficult while we are producing clinker in the rotary kiln, because all these plants are very high capacity plants, 10,000 ton per day clinker production. We can't take any undo this thing without understanding the mineralogy of this thing. So this type of analysis will be helpful while we are putting under the usage in the plant. And this I have shown you some of this, the graph, whatever is coming at different temperatures, how the peaks will go and how it will come down. So this is for study and taking the corrective actions. But these type of equipments, when I mentioned TGA and DTA analysis, is generally not being used on a regular basis for quality assurance department in the cement plant, but it is required for research and development, and when you are looking for some different type of raw materials in order to check our cost, etc. And another one is differential scanning calorimetry, which I shown here. This will be also used like a DT-ATG analysis. Instead of weight changes, the heat transfer is being recorded, and you can come to know about the hydration kinetics of the cement and even gypsum dehydration, because gypsum dehydration is a very important aspect while we are producing cement, and is also very important for application point of view, because gypsum, you are aware that it is CaSO4 2H2O. When we are grinding the cement along with the gypsum in the cement mill, if cement mill temperature exceeds more than 120 degrees centigrade, so this gypsum CaSO4 2H2O will be reduced to CaSO4 half H2O, like that, and it will create a lot of problem in the concrete, whether it is fall set or flash set or generally fall set, and the slump loss, etc., and flowability, etc. So it is very important for cement manufacturers, because cement is not an end product. End product is the concrete. So this concept we are regularly putting inside a cement plant people who are working here, because this has to be told very clearly to the people who are working in the cement plant that cement is not an end product. Concrete is the end product. So this type of thing, when we are sitting in a leadership position in the cement industry, we are professing this type of culture inside the cement plant, saying that you should have a lot of empathy about your customers, your consumers. So all this humility, empathy, etc., these new things we started putting inside the minds of the cement workers or cement managers who are working in the cement plant, so that they should think in the shoes of civil engineers who are using our cement, and find out what type of problem they are encountering while using the cement. So this is a new thinking, and we are continuously on the job, and because in the inside the plant also we are practicing uh, the supplier and customer relationship. If some department is a customer to some other department, and some other department is a customer to supplier to other department, so this type of customer supplier relationship we are professing in the cement plant, and trying to cultivate the thinking in that manner, so that there should be a good understanding about others problem also. So these are certain things, isothermal and adiabatic calorimetry. These things are not being used in the cement plant on regular basis, but yes, we are using this type of equipments in the R&D purpose. When I was with Ultratech, we have developed a very good R&D center, investing around 20-25 crores of rupees, and I have got the privilege of putting so many new systems in the cement plant. For example, online analyzers, and in the next slide I will show the robo laboratory, etc., how it works. So when I was with Ultratech and Lafarge in Asia, we have established a very good laboratory with all hi-fi systems, and I made that it should work in the cement plant, and they should take the advantage of each and every equipment to the fullest potential possible. So this was a big challenge, and during this challenge, a lot of learning also has gone inside, and which has improved our confidence level, and also to show to the customers who are visiting. Actually, we started inviting our consumer or customers to the cement plant to look at the system what we have, and look at the technology what have been implemented, so that it will give a lot of insight to them, and they will after in turn it will create a lot of confidence level on the higher side. So this type of thing also we have been doing, inviting our customer base to see all this new technology, and how they are maintaining the quality, and what is the level of understanding of the quality who are working in the plant. So this has given a lot of mileage to us to target the customers, and to take the customers to in our fold, because these people are the dealers or the civil engineers or learned fraternity like you. So they are all the decision makers and influencing segments. So in order to show our capability and competency in the manufacturing of cement and quality, so the influencing segments will have uh, a the confidence level, and they will come forward to take our cement and putting this under use. So this is one is a very important thing. The scanning electron microscope and optical microscope, they are two different things. I will first talk about the optical microscope. You must have seen that in optical microscope there are two things are happening. One is that you will make a thin section of a rock or of a concrete or of a clinker, make a thin section. It is less than 0.2 mm or something like that. Very small thin section we will make, and then that thin section will be putting under the microscope, and we will observe the microstructures and identify the different minerals, how they have been arranged, what is the microstructure of that, and what is the porous things will be there. Everything will be understood by studied under the optical microscope in thin section. Similarly, we are also using the polished section of the clinker, or the powder microscopy for cement, in order to understand its microstructure and how it has been arranged. In case of clinker, we will polish the clinker, and then the polish, it will take a very good polish if you are following correct procedure, and you can see your face on the polished face. It should be the kind. When you started looking your face on the polished section, that means it is very good polished section, which is ready for under observation under the microscope, and you can do it, you can study it. So here I have shown you the microscope and its different parts. One is thin section, which you have seen in the first one, and second one is the polished section. Also you can put it on the table of this, and you can observe the polished section and its microstructure. And third one, here I have shown that microscope is attached to a computer thing, which is called image analyzer. So image analyzer is nothing but whatever section you are observing through under microscope, and you have to identify what is C3S, what is C2S, dicalcium silicate, aluminoferrite, dicalcium aluminate, etc. So you will come to know about the microstructure, how they have been arranged, and what is the percentage of this. How much is the tricalcium silicate or halide? How much is belite? How much is silite? Like this. So earlier days we used to count this thing each and every phase manually. So it is taking a lot of 3 hours, 2.5 hours to study one sample. So with the advent of image analyzer, within 10 minutes you will complete all your analysis, and you can come to know about the microstructure and its percentage presence in it within no time. So this has helped a lot. This is also one of the good thing has happened, and you can publish a lot of research papers. You can do you have to use your wisdom and knowledge and this thing to analyze all those samples and put it in form of, you can produce a very good report. So this is a section I have shown. First one is a thin section. This is called this is transmitted light microscopy. When I say it is a thin section, which is a transmitted light microscopy. So here you can see in the picture, it is a thin section of a calcite, calcium carbonate. So this is how it looks. Depending upon its polarizing properties, we used to identify what is the mineral presented. You can see some of this undulation extinctions. This is the characteristic property of a calcite. And second section I have shown you is being placed here is the thin section of a concrete. how it looks, and you can identify what is the matrix and what is this, everything you can study it and how it has been arranged, etc. And third picture is the polished section microscopy picture of a polished clinker. You can see the hexagonal thing, that is a tricalcium silicate, and that brownish color thing is a beta C2S or belite, dicalcium silicate. And the interstitial material in between these two minerals, you can see some of these things, that is either it is a C3A or C4AF. We generally call it as interstitial phases. So how it has been arranged, because in the cement chemistry, when we are talking about the microstructure, there are certain fixed rules that the C3S or C2S or C3S C4F should look like this, and it should be arranged like this, then only it has burnt in a very nice atmosphere, etc. So depending upon the knowledge and experience and your wisdom, people will identify about how this material has been generated, how the clinker has been burnt inside the kiln, what could be the environment at that point of time. So this story or this interpretation needs a lot of experience and knowledge and keen observation on the microstructures to talk about the genesis of these minerals. So another I put it is the SEM, scanning electron microscope of cement paste when it is under hydration. So I don't want to go deep into the subject because the idea is not to talk about hydration products or etc. So which is about the scanning electron microscope, which is a very costly affair, which is costing very high vis-a-vis optical microscope. So this thing will be required for not based for the cement plant on day-to-day basis, but it is very useful for R&D institutes and research institutes to study the hydration products or mineralogy or CSHL, and for the concrete you can do a lot of things. You can make a good research report out of it. So this is a picture of scanning electron microscope. These are when you talk about the cost, just to give you an example, it is costing nearly ₹1 crore. But whereas optical microscope is costing with image analyzer, etc., is around 30-35 lakhs rupees. So this is a costly affair. This is a costly equipment. And these are certain photographs of hydration of cement paste under the SCM, and this is a typical SCM photograph of fly ash. And here I would like to show one video. Here, which I mentioned that the robo laboratory, online laboratory. Okay, so as I mentioned earlier, there are 5-6 finished material, semi-finished materials we use to collect the sample. For example, raw meal, every 1 hour we analyze, and the kiln feed and clinker and cement, every 1 hour the sample will be collected and being analyzed manually, and collection is manually. So this was a scenario around 10 years ago or 15 years ago. And once this online laboratory or robo lab has come into the this thing action, many cement plants, big companies are started putting, which I already mentioned that I had a privilege of establishing more than 6 to 8 robo laboratories in Ultratech, and more than 10 laboratories in Lafarge, Asia, in Japan, Korea, all these places. So just to give you a sort of information about this, I'm showing a video. I think it will give a lot of insight to you. So Professor Saab, I will start the video. Kindly let me know the sounds is coming or not. Huh?
Yes, sir.
Is it okay?
Sound is not coming. Sound is not coming.
Not coming. Okay. So you can see this thing. I will give you the interpretation commentary. So this is a robo laboratory, industrial robo, which is a control room of robo in the cement plant. cement, different samples are coming from different locations in the cement plant to this laboratory control room. And this robo will receive the sample and putting under XRF, it will prepare the sample and putting under XRF for analysis. And also it will also put this material inside the particle size analyzer for analysis. So no manpower is required. It is receiving the samples from different locations which are coming through capsules automatically through a pneumatic conveying system, and put it on the laboratory XRF belt, and it will be analyzed automatically. You can see it is preparing a sample for particle size analyzer and putting inside the particle size analyzer. Okay. So there is no manual entry. There will be automatic sampling. No human this thing is there, and everything will be analyzed and stored in a laboratory information system software. This is called LIMS, and it will store in different places. For example, analysis of raw mill will be stored in a raw mill slot, kiln feed slot, clinker slot like this, and every hour this will be analyzed and the data will be stored there. And you can use the data bank for your analysis. If you want to study statistically, you can do it. You want to do statistical analysis like different histograms or what is the statistics of that. Everything will be, you can make a study out of it. Whether you want 6 month data, you want 1 year data, or you want 2 year data, everything can be retrieved within no time. And you can do statistical analysis and find out the trend analysis, so that you will come to know and will give a lot of insight, the historical data, to proceed further. And also take you can chalk out the next strategy for this. And here I would like to tell you that at different, even the plants are equipped to dose the system automatically, because manually it used to do in manually in cement plants earlier days. Nowadays all are equipped automatically. The dosing system I will automatically put whether we need 2% or 3%, depending upon the chemistry, it will automatically set by itself. There is no human intervention at all. So in cement plant, in the modern plant, people just coming, sitting in the level in the quality assurance control room, and similarly in the process control room, that is centralized control room or CCR, people will just witness what is going on. Even the pyro processing also, the software will take care of itself, depending upon the parameters what we have set to be maintained. It will automatically take corrective action. It will automatically does everything. So there is no human involvement, and the action will be momentarily, without waste of time. It will be taken care, and things will be online. So you might have heard that there is autopiloting. So generally in long haul flights, what these pilots will do after reaching around 38,000 feet or 40,000 feet, they will put the navigation on auto mode. So in the cement plant also, used to put this thing on auto mode. So just people are coming and seeing what is going on, just observing, and intervene whenever it is required. So in the autopiloting also, if the weather condition is a problematic, the turbulence will be there, and then the pilot will intervene. So similarly in the cement plant also, we will only attend when it is required. Otherwise, it will be running, by the software, and everything will be taken care. So just observing what is going on. So this is the new cement plant picture I try to give you. I don't know whether you have got all these things feel, but we invite you to come to state-of-the-art cement plant and have a look at it. It will be a wonderful experience according to me. So with this, I try to complete, and with a very good quotation of Dr. Abdul Kalam. So I used to finish on this line and hand over to Dr. Agrawal.
Thank you, Dr. Hegde, sir. I am very grateful that you introduced many of us for the first time to RoboLab and such videos and some such photographs. And I personally was not aware of such developments in the cement plants. And
Okay.
of course, you rightly told that now the shift is coming to cement professionals, that these people need to know, cement plant people need to know that the end product is concrete. Basically, I remember once I visited Ultratech plant where B.N. Mahapatra ji was GM in 2012, Vikram Cement. And so I went there for taking my daughter to training. She was so, but he utilized the day. Dr. Mahapatra, actually, you know Ashok Tiwari ji. So Ashok Tiwari ji might have given him some inputs. So Dr. Mahapatra used that opportunity to take me to his team, and I had a session with his team on concrete. Of course, what is the cement quality required and what we look into while concrete. So I had a very good discussion with his team. So I remember those days. And then, of course, you talked about R&D center of that Ultratech. That also I happened to be involved in some time with the advice of Professor Tiwari, A.K. Tiwari. So I am aware that you have been involved in large research and development, particularly product development in the Lafarge, and so I am very grateful to you. But here our one doyen of our concrete, Rajamane sir, is here. You may kindly check the chat box. He has written some queries. You may reply him. I have given your contact number to him. So for general interest, if you wish to reply some of them, you may kindly.
Sure, sure, sure. It is my pleasure.
Any other participant also may also kindly ask any query.
Dr. Hegde Saab, this is KRS Narayan. Excellent presentation.
Good afternoon.
Good afternoon, sir. It was a great presentation. In fact, it's just like how Professor Agarwal said that it was enriching experience. It was phenomenal experience for me too. So, Doctor, I have only one question, Doctor. Can you update the status of the external carbonation for non-hydraulic cements? Because 2 years back, ASTM started working on that. And then there was no progress based on the 2018 committee. But since you are a doyen of cement industry, can you please throw some light on external carbonation or external sequestration of CO2 for non-hydraulic cements? Thank you, Doctor.
Yeah, Narayan Saab, whatever you know, I also know that, and give me some time to check really, because I don't have the whatever the ready answer with me, because I have to check it this thing, and I will come back to you.
Please,
so
please, Doctor. Thank you. Thank you, Doctor. Thank you.
Will come back to you, and I will also educate myself on this. What happened to that after 2018? This thing.
Yes, Doctor.
Because since I'm involved in on the manufacturing of cement and administration of the cement plant.
Yes,
Small, this thing I definitely look into, and I'll come back to you.
Thank you. Thank you, Doctor. Thank you. Thank you so much.
Thank you very much. Thank you.
Hello.
Any other? Yes, sir.
Rajamani here.
Rajamani, sir.
Good afternoon. Very nice presentation by Hegde, and
Okay.
and also the comments by KS Narayan also, and yours also was very good.
Thank you.
I don't know whether Hegde has got time to discuss these points I have put in the chat box, but anyhow, he can clearly tell us what is the difference between, or what is the difference between finding the bogus compound by microscopic analysis, by XRD, and by that calculation equations are given. Out of these three, which is the one which cement plant uses?
No.
Are you able to hear me?
Yeah.
Hello.
I clearly you are quite audible, and I would like to say that Bogue formula, what we are doing in the cement plant, it has got its own limitations. Okay. So suppose example, if we calculate the C3S content or the phase composition.
I know that it is a limitation. A small change in the percentage will change the compounds quantity very much. I am aware of that. That Neville has explained this very neatly. Okay.
Yes.
Now that means Bogue's equation cannot be used. Okay. The equation given in the codes cannot be used. So that means we are left with this XRD and microscope. Tell me what is the difference between these two? Which one you are using?
No, XRD, that is Ritwild analysis is there. This is the latest thing.
No. I want to see the XRD. Okay, go ahead.
No, XRD with Ritwild analysis. So we can quantify the phases of.
Okay. No, just can I interfere here?
Give me one second.
Okay.
And microscopy, microscopy, yes. If microscopy is a useful analysis, provided the microscopist should have the required knowledge and experience. Otherwise, it is of no use.
No, microscopy requires etching,
Many cement plants has got the microscope, it has become a showpiece.
Yeah, exactly. No, I want to know microscopy requires etching also, proper etching to identify the box. Is it right? Yes. So etching is a really
yes, because
yes.
Etching, Rajamane sir.
Yeah.
Etching, even right from sample preparation of whether it is a concrete or it is a clinker, which is itself is a art. Okay. Then number two, once you prepare the sample for observation, then etching is also another challenging thing and which needs a particular skill.
Okay.
Because
XRD becomes very useful. XRD is very useful.
Very useful. So in etching also, for example, you might be aware that the HNO3 or the different concentration of HNO3 is useful for tricalcium silicate. But it may not be good for etching tricalcium aluminate or ferrite. So we have to use different etching methods. So we have to use different etching agents. So that itself is a challenging job.
Yes.
And it is consuming lot of time. It is consuming lot of time. It is a very tedious thing.
Yes.
And number one. Number two, the sampling of clinker or whatever material is another question mark. Because cement plant, if you see, it is 1,000 tons per hour.
And you're taking only micrograms. Yeah.
So collection, the sampling, the required sampling procedure itself is a big task. And you are observing only few nodules.
Micrograms you are collecting.
That is exactly.
Yeah.
When the sample is not representative, whatever we are doing will be a waste of energy and time.
Yes. So the statistical analysis and sampling.
Yes. That's the most important thing.
So I want the civil engineers to become aware that how much cement plant is doing the best for them to get the same cement from the cement plant as per IS codes. And these people, we people, don't bother about that and misuse the cement on the site and are not able to produce even M20, M21 on the site and blame the cement plant for every problem in the concrete. I wanted them to understand that how critical the cement plant is working. Just I wanted to know, and also I wanted to know myself also how you are going through these phases. And also, suppose I get a cement, I want to analyze myself, okay, for some purpose, okay, because we cannot send that sample to you, cement plant people. So what is the way I think we should be aware? How do we analyze the XRD for quantification of Bose compound? Can you explain? Not now, later on also. Because XRD gives only the peaks and that half. Okay, anyway.
No. Yes.
Because I want to
exactly
use XRD for finding for geopolymer concrete. Also, my interest is next.
Yes.
So yeah.
So sir, I request Dr. Hegde ji to kindly interact with Professor Rajamane sir individually. If any other participant has any question, of course, Rajamane ji goes in very deep. So so deep, general participant has not been able to go inside. Anyway, other participants, if any query with the learned speaker, sir. With all regards to Professor Rajamaneji and other participants, I wish to close this session because our chief guest of the valedictory has already joined us. So we will be starting valedictory in a few minutes as the Vice Chancellor sir joins us. And so I wish to express my deep gratitude to the learned speaker, Dr. Hegde sir. And thank you so much, sir, and for sparing time and sharing sharing this online. Thank you. Online and offline tests, particularly online tests. This has enriched our knowledge, as rightly highlighted by Narayanan sir also. So I am very grateful to you for being with us all throughout 5 days. Rather, you spared time to join us and add value to in many of these sessions. So I am very grateful to you on behalf of Rajasthan Technical University Kota, as well as on behalf of myself personally as well. So with this, I end the technical sessions of the AICTE FDP on the green technologies and sustainability engineering here with the contents, specific contents on construction materials from industrial waste for sustainability. Now, we look forward to about half an hour program in which we will like to hear from the participants their feedback, as well as our honorable guests' views. So I welcome Professor Anil K. Mathur sir, our Dean, Faculty of Affairs, who has joined. And Mathur sir, please.
Thank you.
Professor A.P. Singh Sab has already joined. He is Dean Academics, UG Studies, BITS Pilani. So I welcome Professor A.P. Singh sir.
Good afternoon to all of you.
Afternoon.
Good afternoon, sir.
Good afternoon.
One just announcement for the participant. One quiz is slated to be, one online quiz is slated to be given for the participants that we shall open at around 2:30 p.m. So participants are requested to fill that Google form. Maybe 15 minutes time will be given to them to fill the quiz. This is mandatory quiz, as the many participants knows this thing, that AICTE generates participation certificates for those only who score minimum 60% in that quiz. So that's a formality. Of course, most of you have been with us in every session, so that's only a last formality of the FDP. माथुर साहब वाइस चांसलर सर को रिक्वेस्ट कर लिया सर.
हाँ सर को फोन कर दिया, सर ज्वाइन करते हैं 2 मिनट में.
सर
कैसा रहा आज का सेशन आपका?
हाँ, डॉक्टर हेगड़े जी ने बहुत अच्छा ऑनलाइन टेस्ट के बारे में बताया. हमारे साथ एक 2-3 रिसोर्स पर्संस भी जुड़े हुए हैं अभी. हमारा डॉक्टर के आर एस नारायणन सर हैं, रिलायंस इंडस्ट्री के हेड बिजनेस, और डॉक्टर हेगड़े जी तो हैं ही उदयपुर सीमेंट वर्क्स के, और एक हमारे साथ अभी सुबह मैडम भावना त्रिपाठी जी थी, मणिपाल यूनिवर्सिटी जयपुर की डायरेक्टर सिविल एंड केमिकल इंजीनियरिंग, और भी एक और जुड़े हुए हैं हमारे साथ बड़े एक्सपर्ट, प्रोफेसर राजामाने सर. ही हैज बीन इन स्ट्रक्चरल इंजीनियरिंग रिसर्च सेंटर. So we have a galaxy of experts here. So I will request in a few minutes, few of the participants to air their views about the FDP. So 3 or 4 of you may please raise your hand or unmute yourself in one by one and tell in maximum 1 to 2 minutes about your experiences and suggestions to us for further improvement in future. It is only on voluntary basis who wish to speak.
I'm on webinar or important webinar with cement manufacturing.
What I propose is that I will present a report in 2-3 minutes about the FTP, maximum 3 minutes. Then I will invite the participants for their feedback. And if 1 or 2 resource persons also stays with us, they are also welcome to share their experiences and suggestions and advice to us. And then our Dean, Professor Mathur sir, will give us some blessing words, and then request our chief guest of today, Professor A.P. Singh sir. And in the end, we will request our Honorable Vice Chancellor sir to give us his advice for future and purpose. In the meantime, I will like to share the feedbacks received on the current session, which this Dr. Hegde sir has given us. So, if permitted, I will just share the feedback. Any one of you may kindly confirm if it is visible to you. The feedback is visible. Kindly confirm. Say, as you can see, we have asked to write participants in a line major takeaway from this session and rate on a scale of 0 to 3, 3 being excellent. Welcome, sir. Honorable Vice Chancellor, sir. Honorable Vice Chancellor, sir, if permitted, we may start the valedictory session, sir. Honorable Vice Chancellor, sir, if permitted, we may start the valedictory session, sir. Mathu sir, please. Anil Mathu sir. I hope I am audible, sir. Anybody may kindly confirm that I am audible.
आ रही है सर, आपकी आवाज आ रही है।
Yes, you are audible.
Sir.
You are audible, sir.
हाँ सर। माननीय कुलपति जी अगर परमिशन दें तो हम वैलिडिटी चालू करें सर।
सर ने ज्वाइन कर लिया क्या?
हाँ सर, हाँ सर।
सर गुड आफ्टरनून। सर का माइक म्यूट है क्या?
तो वो ही अनम्यूट कर सकते हैं सर, मैं नहीं कर पा रहा।
अच्छा,
वीडियो भी नहीं दिख रहा सर, का नाम दिख रहा है सर।
कॉल करता हूँ
सर। नमस्कार सर, गुड आफ्टरनून सर। माननीय कुलपति सर अगर इजाजत हो तो हम वैलिडिटी चालू करें सर।
अभी मैंने बोला सर को अनम्यूट करने के लिए।
सर
मेरा मूड खराब हो रहा था, मैंने इसको लिखा कि साले तुम जो है कुछ नहीं कर रहे हो और यहाँ पे कैश नहीं हो रहा है, लोग परेशान है, तो मैंने सुबह लिख मारा इसको। वो आया मेरे पास, कबूल सर ये क्या है, मैं यार करते ही नहीं हो तुम लोग, कागज को लेके बैठे हो। ये है। हेलो माथुर साहब, मैं आ गया हूँ।
हाँ सर, सर स्टार्ट
सर। नमस्ते सर।
मेरी आवाज थोड़ी कम कर रखी है शायद, क्या आवाज आई है आपको?
हाँ सर,
हाँ सर आ रही है सर।
गुड।
सर इजाजत हो तो चालू करें सर वैलिडिटी।
या बिल्कुल, आप शुरू करें।
Sir, it is my proud privilege to present a small brief report about the faculty development program which was organized under the aegis of AICTE ATAL. The theme was Green Technologies and Sustainability Engineering, with particular contents on construction materials from industrial wastes for sustainability. Already shared, we had participants from 19 states of India, and our resource persons comprised of researchers and industry stalwarts who have been, particular emphasis was to involve people who have been active in last 1 decade or so. Of course, some of the experts are active since last 2 decades, have experience of more than 2 decades, but particular emphasis was to involve even postdoctoral fellow from Switzerland, sir, in concrete research and in the construction materials from industrial waste, the research hubs in the country. One is IIT Delhi, one is IIT Hyderabad, of course, one is an MNIT. Another is for bulk uses CRRI, Central Road Research Institute. And of course, implementing agency as the NRIDA, National Rural Infrastructure Development Agency, all were involved in this. As we learned that more than 70% of our roads are rural roads. So Dr. I.K. Pateria, who is heading since last 7 years and more in that capacity of Director Technical, himself spared time for sharing his experiences and how the waste materials have been used and technologies are being developed in bulk use of these materials. He rather ended on a very good note yesterday that if everything goes on as the planned one, Niti Aayog has also done some guidelines. So we will have bulk use of plastics in roads in 2-3 years coming up in at the most 4-5 years. He has already shared that in Madhya Pradesh, more than 7,000 kilometer roads have already been built using that plastics. Similarly, IIT Hyderabad core group of concrete, Dr. Professor KVL Subramaniam, who developed all instrumental analysis and characterization there. Dr. Bhagat Singh, who did PhD under him and then postdoctoral at Switzerland and then Singapore, joined with us and of course talked about geopolymer concrete. Today we have Dr. Rajamane also, he is a stalwart in geopolymer concrete in the country. So then IIT Delhi group, everybody in the concrete field knows Dr. Bhattacharya, Professor Bhattacharya. He is rather Bhishma Pitamaha of concrete in India. Everybody knows him. So Professor Bhattacharya's research lab, Dr. Kevan from SVNIT Surat shared his experiences and shared everything about mercury imperoximetry and microstructure of concrete with these waste materials and their durability. Then IIT Indore, of course, MNIT, during his stint at MNIT, Dr. Sandeep Chaudhary had guided various PhDs. So Dr. Trilok Gupta, Dr. Bhavna Tripathi, and Professor Sandeep Chaudhary himself, they shared their knowledge and shared their research work in different areas, say stone processing dust, zinc refining waste, rubber ash, and over theme lecture was given by Professor Sandeep Chaudhary. Dr. KVS Narayanan is head business at Reliance Industry. He set the ball rolling and he aroused interest. And being in a very senior position also, then also he spared time to attend most of the sessions and rather gave his inputs in most of the sessions. Then we had Dr. Hegde. Hegde ji is our Rajasthan, he is serving in Rajasthan, so we take liberty from him. We take his time whenever we wish to, and he is so kind that he shared just this session, in this session which has just concluded, he shared how robots are used in online analysis and shared the development at Lafarge Cement, Ultratech Cement. He is in JK Lakshmi Cement nowadays. So all cement companies discuss the state of the art, testing procedures and everything. So thus, and Central Road Research Institute Chief Scientist, Dr. Professor Guru Vittal, shared his research experiences and implementation difficulties and issues and case studies presented for fly ash in roads. Guru Vittal has been in the high-level committee of Rajasthan in 97-98, which paved the way for whole utilization of pulverized fly ash and national highways in the Rajasthan as well as in the country. Rather, he has been in the forefront of utilization of these waste materials in the country. And of course, top of it, our Bureau of Indian Standards. Head Civil Engineering, Shri Sanjay Panji himself spared time and explained in detail what are the provisions of specifications for use of these materials and what are the codes, how can they get the codes, how can they contribute in framing the codes. And he is the man, sir, who revised who was the main key person who revised the IS 3812, IS 1489. These was his personal missions, which has resulted in bulk utilization of these materials, waste materials in the country. So with a galaxy of experts, our participants took a very good interest. So most of the time, 75 plus, 80 plus participants were attending at a given time. Google gave me attendance, sir, so which shows that on a day, on an average, 100 participants participated. With this, I request few participants to air their feedback, their own views, how we can improve upon. Participants may unmute themselves if permitted by Vice Chancellor, sir. 2 of them or 3 of them may air their views in 1 minute and 1.5 minutes, sir. Any participant may please like to air his or her views by unmuting yourself.
Okay.
Yes, Professor Prasad sir. Prasad sir. Yes.
Good afternoon, sir. I am very happy to attend this course on green mission, which is the need of the hour to clean our environment. And in the last 5 days, most of the topic which were covered initiate the utilization of the various waste which we create during the process of different materials. And all the experts which has been provided by Rajasthan Technical University Kota and the coordinator Dr. P.K. Agrawal were excellent. The mode of presentation was very good, and the major thing was that all the lectures were started at the right time. That is, the punctuality of the Dr. P.K. Agrawal has been shown for organizing such a galaxy experts to all the participants who had attended. Thank you, Dr. P.K. Agrawal, and also the Vice Chancellor, RTMU, and Deans and Head of Civil Engineering Departments, and all these colleagues to organize such a nice program. Thank you very much.
Thank you, Professor Pusatkar ji. He is from Nagpur, sir. Any other participant, please?
Hello.
Yes,
Hello.
Raja. Yes, please, sir.
This is Rajamane. I was in CSIR SERC laboratory. Then after retirement, I worked in SRM University. I worked on all types of new concretes from the 1973 onwards up till now. And I know P.K. Agrawal since his days in University of Roorkee, and now IIT Roorkee. And whatever he does the best. So I can see that this series of lectures were well planned, and speakers were also of a very high quality. And though I could not attend some of them, and today Dr. Hegde's program was excellent. I think a civil engineer should know that how much care is taken in cement plant to produce the cement for the civil engineers use. I think if such schemes, such lectures are arranged in more detail, civil engineers, especially in academic and research field, people will know that we should use the cement properly. That is the need of the hour. And so I think it has served well. And regarding the sustainable materials, it is very much required. I think we can have one separate real program on geopolymer concrete also, where carbon footprint is very low. So actually Dr. Agrawal is already aware of that, and he has given opportunity for me to present that topic also. But on the whole, this program was very useful, and I wish Dr. Agrawal all the success in the future programs of this nature also. Thank you very much, sir. Thank you.
Thank you. I can see one lady participant if she wished to add something.
Sir, I would like to add something. And thank you very much for giving this opportunity to interact with such lovely research professionals. They have added to the knowledge which we have recently obtained regarding a lot of waste management. People are focusing much more upon waste management strategies these days, and the advancements in recent sustainable technologies is really enlightened with all the arrangements which you've made. And the expert lectures were excellent. They added to a lot of knowledge and the latest trend which is going on in the research field these days. I thank you all the organizing committee and especially Agrawal sir for arranging all these wonderful lectures. I'm from IPS Academy, Indore, Dr. Devanshi Jagwani. Thank you, sir.
Thank you, madam. Uh, I hand over the mic to Professor Anil K. Mathur sir, our dean sir, for his blessings and his address, sir.
Thank you, Pravinji. I welcome all the participants and dignitaries in the valedictory program of Green Technologies and Sustainable Engineering. This program is organized by Department of Civil Engineering, and coordinator is our enthusiastic academician Dr. Praveen Agrawalji. And this program was sponsored by AICTE under the ATAL FDP program. So I would like to also thank to AICTE for sponsoring such programs to RTU. And for the information of all our participants and experts, I would like to inform that this is probably the third FDP ATAL program which RTU has organized in last few months. So I welcome our Honorable Vice Chancellor Professor R. A. Gupta Sahab in this valedictory program. He is very kind enough to join this valedictory program, and he was also present in inaugural program of this AICTE FDP program also. And under his leadership and under his guidance, our institute is progressing day by day, and he is very motivating. He motivates all our faculty members, not only for teaching, but also for other courses, other faculty development programs, other research projects from AICTE and from other institutes. So I am very much thankful to him for his guidance. Now I welcome our chief guest of the function, Professor Ajit Pratap Singh. He is Dean, Professor of Civil Engineering and Dean Academic at BITS Pilani. He's my friend, and he's a very nice academician, very expert in the fields of green technologies and water management, wastewater management, etc. I also welcome the expert who are present in this program, SB Hegde ji, Rajamani ji, and all others. I also welcome all our participants, our teachers, faculty members, students who are joining this program. And as Praveen ji has informed that almost every day 100 participants are present, so it is a very nice number, and it indicates that all the faculty members are really interested in green technologies, which is the topic of the day, the topic of the year. We are facing number of problems related to environment pollution, air pollution, and all this COVID. So we need to have a green technology and sustainable engineering in our life. So I'm thankful to Praveen ji for organizing such type of event, and we can understand with the feedback of participants that it was a very great success. All experts were very eminent in their fields, and they have imparted knowledge to all the participants. So I'm thankful to all of them once again. Now I would like to request our chief guest, Professor AP Singh, for his views. Before inviting Professor AP Singh, I would like to present his brief introduction. Professor Ajit Pratap Singh is presently working as a professor of Civil Engineering Department and Dean Academic Undergraduate Studies, which is Institute-wide Dean for Pilani, Goa, Hyderabad, and Dubai campus at BITS Pilani, Rajasthan. He received a civil engineering degree from BITS Pilani itself. He is a fellow member of Institution of Engineers, fellow of Indian Association of Hydrologists, He is also an active member of Indian Society of Hydraulics and Indian Waterworks Association and Institution of Public Health Engineers India, and he is also a member of Eastern Asia Society for Transportation Studies, Japan also. Academically, he is a very sound and very renowned person. He has published over 90 research papers and reports. He has also served as the professor and head of department civil engineering, BITS Pilani Dubai campus, United Arab Emirates for 2 years. He has more than 25 years of teaching and research experience. He has taught as many as 20 different courses of civil engineering. He has also delivered invited talks for various training programs and workshops. He has guided 9 doctoral theses and over 45 master's dissertation program, and currently he is also guiding 2 PhD students in research areas of real life importance. He has completed many research sponsored projects on the socio-economic assessment of construction of rural roads in India. He has also been actively involved in various sponsored research and consultancy projects related to water quality assessment, water pollution analysis, prediction and management of surface water, groundwater contaminant transport modeling, and also socio-economic assessment of construction of rural roads, etc. He has been actively involved in reviewing various research papers submitted in his field to more than 35 journals of international and national repute. Dr. Singh is also a member of Senate and many board of studies at different universities. He is also a member of Research Board or Doctoral Advisory Committee member of UGC. He is also expert member in various public service commissions. He is expert in selection committee of Ministry of Environment, Forest and Climate Change. He is also third party expert for various projects under JNN, URM, PMGSY, PWD, NHAI, PCI schemes funded by central and state governments. He is also a member of working group expert member of NIH Roorkee, coordinator PMGSY Roads, National Rural Infrastructure Development Agency, Ministry of Rural Development. He has also worked as the commissioner appointed by the Honorable National Green Tribunal, New Delhi, for assessing the status of environmental quality in different rivers and industrial clusters. So, looking to his profile, he is the appropriate person to give his address as a chief guest in this Green Technology and Sustainable Engineering FTP. So, I invite Professor AP Singh for his views.
Thank you, Professor Mathur, for my introduction, and good afternoon to all of you. Am I audible now?
Yes, sir.
So, good afternoon to all of you. Respected Honorable Vice Chancellor Sahab, Professor R.A. Gupta ji, coordinators of the program, Professor Anil Kumar Mathur ji and Professor Praveen Kumar ji, Professor Dwivedi ji, faculty colleagues from engineering colleges and polytechnic colleges, research students, ladies and gentlemen. It is indeed an honor and privilege to be part of this valedictory session of AICTE ATAL Faculty Development Program on Green Technologies and Sustainable Engineering, organized by Department of Civil Engineering, RTU Kota, during December 7 to 11, 2020. I am thankful to the organizers for providing me such important opportunity. So as we have seen in this 7 to 11 5-day program, we have been facing several environmental problems due to rapid population growth, urbanization, and industrialization. As a result, we experience effects of even global warming and climate change, and because of which we face flooding and droughts situations in different parts across the globe. Per capita water availability is reducing, health and environment are in danger now. So, of course, our engineers, scientists, researchers around the world are developing technological solutions aimed at reducing and eliminating such problems. So, why this green technology and sustainable engineering is important? I will give you 1 or 2 examples through which I will try to draw your kind attention. So, recently I was, as it was introduced, I was a part of National Green Tribunal committee to assess the pollution level along river Jojari, which is basically originating from Jodhpur. And one industry, so if you know, there are in Rajasthan case, if you see, there are three main industrial clusters: Jodhpur, Pali, and Balotra. So if you take example of Jodhpur, there are about 420 industry, mainly about 390 textile industry and another 95 to 195 or so steel industry, and they produce a lot of wastewater. And because they are small and medium sized industries, so definitely they cannot have the complete treatment plant. Rather, the concept is of common effluent treatment plant, where actually the wastewater is to be treated and then it is to be reused or recycled. So ultimately, what is happening? The treatment, common effluent treatment plant is treating the wastewater of about those 420 industries of about and around 10 MLD of wastewater is being treated. But ultimately, when you see the Jojari river, you get a lot of wastewater which is untreated, and directly it is it is being disposed in the river. So what is happening that if you see the particular different villages along this river Jojari, like Doli and Doli or Araba village. So in 2014, whatever through sustainable technology tools like ISRO satellites and all, what I observed that in 2014 the affected area was about 170 hectare in that particular village. But if in 2018 it has reached to 406 hectare. So that itself is showing that 138% area is affected because of the wastewater, and as a result, the freshwater bodies like wells and all those things, they are completely flooded with the wastewater, and the villagers are not getting fresh water in those area. In fact, cattle are also facing a lot of problem because of unavailability of fresh water. So this is just, I am giving one example that we are generating the wastewater because of our development process, but actually we have not adopted the green technologies or the recent technologies or energy efficient technologies through which actually we could have treated the wastewater. So say for example, if we can adopt different technologies like membrane filtration or microbial fuel cells, nanotechnology, development of biological treatments and natural treatment systems such as wetland, etc. So by those processes actually we could have treated this, and in fact we need to treat it. So all these processes are used to make water drinkable or significantly reduce the presence of pollutants from what is discharged into the sea and river. So in fact, if we adopt green technologies and sustainable engineering, definitely we can able to get the solutions. It is not that we are not doing or we are not developing technological solutions, but definitely we need to do this on aggressive scale. In the same way, I think one of the speakers just now was talking about cement and all. So the concept of waste to energy is very much to be encouraged, and people are following on this. So one of my PhD student, he has conducted the test on utilization of fly ash and copper tailings. And what we found that whatever target strength of cement, say M40 grade cement, M40 grade concrete, when we want to produce, the reduction, we have found that we can reduce the cement about 10 to 12% if we are going to mix fly ash and copper tailing in that. And in the process, we are also able to reduce about 18 to 20% carbon emissions from the replacing the cement with this fly ash and copper tailings. So we can adopt different technologies and different solutions. Say, for example, we can also talk about air pollutants in the industries, which can significantly reduce the greenhouse gas effects if we properly manage. Methane and carbon dioxides are substances that harm the environment. Industries such as chemical, petrochemical, pharmaceutical, etc., must eliminate their emissions so as not to cause serious environmental damage. Similarly, we should talk about and we should implement the recycling and waste management processes. Now, people are talking about blockchain concept, where we should able to have proper recording of the particular product and its waste, which is going to be generated after its uses. So the increase in household and industry waste has been disproportionate nowadays. Managing solid waste should be the commitment of companies as well as individuals. The outstanding technologies such as smart containers, automated food waste tracking systems, and automatic optical scanning technologies can definitely help sort mixed plastics, etc., through blockchain concept and all. We can also talk a few more green technologies in the form of self-sufficient buildings, which are basically constructed by generating energy themselves without the need of an external contribution. One way to achieve greater production with the same surface of photovoltaic panels is to incorporate intelligent solar tracking systems and all. So there are different ways by which actually, in fact, another area is nothing but this vehicles, working on vehicles that do not emit gases, known as ecological vehicles, which are so called because their use does not negatively influence the environment and contributes to reducing the presence of polluting gases in the atmosphere, mainly carbon dioxide, carbon monoxide, nitrogen dioxide, etc. So because of this development process, of course, we are facing a lot of challenges. And in 21st century, we are going to face is especially related to sustainable supply, food, water, and energy, how to curb climate change and adapt to its impact, how to design a future without pollution and waste, how to create efficient, healthy, resilient cities. And these challenges ahead are, of course, substantial, but every day we are making progress both by adapting existing knowledge and skills and by advancing research and innovation to generate new insights and achievements. By refocusing and rebuilding its efforts to advance practical, impactful solutions for humanities, uh, we will definitely adapt future in a much more greener way. So I am sure the program of this kind not only create awareness among different stakeholders of our society, but also play crucial role to invent, adapt, and own. Ownership is also very important. Own energy efficient technologies in this period of dramatic demand change. So I am sure that whatever experience has been shared in this particular workshop program is basically going to be adopted by our faculty colleagues across all 19 states with about 100 participants, and will definitely work on different real life research problems which can curb these challenges. So thank you very much for giving me this opportunity, and wish a great time ahead.
Thank you, sir. We are enlightened with your experience and views on it. I request now our esteemed Honorable Vice Chancellor, Sir Professor R.A. Gupta ji, who has been very kind to be with us during inauguration as well as during the Art of Living session, to kindly bless with his words. Professor R.A. Gupta, sir, Honorable Vice Chancellor, Rajasthan Technical University Kota.
Yeah, good morning, Professor Praveen. Basically, as you mentioned, so many industry experts, so many researchers and experts from the Institute of Repute like IIT and IIT Delhi, Professor Bhattacharya, and then so wonderful, basically galaxy of the speakers and learned professors are there. So this is very encouraging to the participants, especially to me. I'm looking that RTU is doing wonderful work. Then Professor A.P. Singh from BITS Pilani. BITS Pilani, I have visited so many times as expert in the selection of the faculty in electrical engineering. And I am really very much impressed the way many times I quote so many places that how they conduct interviews. All the basically centers, whether it's Pilani or Goa and Hyderabad, all are available at one place, and the faculty, whether it belongs to any center, and they can interview at any center. So that was wonderful. And once, Professor, I want to share that there was 800 applications in electrical, and in fourth, I think 3 or 4 steps, scrutiny was there, and finally we could not select even a single. So tough system you have at BITS Pilani. I'm really impressed, but it's good.
Thank you, sir. Thank you.
And in RTU, Professor Anil Mathur, our Dean Faculty Welfare, and Professor Suneja, Professor Praveen, and Professor Dheeraj Palwalia, and all deans and all HODs nowadays, they are doing wonderful work in TechCube as well. In the TechCube, we are conducting so many basically activities in hackathon and faculty development program, and especially for basically we want to establish so many center of excellence in RTU in so many areas. But this is very important that I want to convey to my professors that in RTU also we have to basically establish, because research is very important and we have to file so many patents. That is also very important, because now apart from this academic activity what we are doing every day, the research we have to develop a lot, and for that we have a lot of money. Money is not a problem. AICTE also basically want to deliver a lot of money for establishment of center of excellence, or to purchase good equipments, components in trust area, in modules of laboratories, and basically so many things. Now they are giving basically a lot of scholarship for the research scholars even, and around 8 scholars seats we have. We are awarded at RTU and TechCube Center. Now we have in electrical department. So many works we are doing, but still I really want to convey to my professors that you at least one best laboratory you have to establish for research in every department. And Professor AP Singh, I want to convey you that money, we don't have problem. You know, nowadays money is a bottleneck in every university. The Rajasthan Technical University, the only university loudly speak everywhere, every place. Money is not a problem. We have money. So the institute which have money, then what's the problem? So this is the issue, and we are talking to government also. And we have, very soon we are going to recruit new faculty members also. We are every day we are speaking with the government. We want to promote my faculty under career advancement scheme. We are working on that also, and my professors, senior professors, they are working hard and they are supporting every day. So Praveen, I want to congratulate you, because whenever I attend your program, it's really excellent. You always invite best faculty, and this is basically very encouraging to all of us. And today I came to know that you did your PhD from IIT Roorkee, University of Roorkee. I am also from Roorkee. So I did my PhD from electrical department from Roorkee long back with Professor Bhim Singh and Professor SP Gupta. So Praveen, whenever he conducts any activity, he really invites always best persons to deliver. So thank you very much, and it's very encouraging, and I am thankful to organizers, especially because, you know, to organize any activity, it needs a lot of inputs. To select best experts, to select best, 19 states, it's a wonderful thing. And every activity needs time. We cannot take lightly. Professor Hegde, I am really very much impressed. Last time he delivered wonderful talk, and again he is with us. So I am thankful to Professor Hegde also.
Thank you, sir.
So thank you very much.
Thank you, sir.
Thank you,
Thank
Professor.
you.
Thank you very much. And I really request you to, whenever we invite, don't hesitate to come. The RTU is family of you.
Sure, sir.
One more thing, I want to on this platform, I want to talk to Professor A.K. Mathur, Anil Mathur, encourage MOU also. MOU with the Seri Pilani we are going to sign very soon, but other MOU, Professor Anil Mathur can do this very nicely. I know he's basically power. So I want that more good MOUs with the RTU. Anil Mathur, you know, whenever I ask, many times he smiles, because I know that he's very much loaded. So many times he may think that, sir, again giving me more work, but what can I do? So these are the professors doing good work in RTU. So thank you very much. And again, we will conduct good activity. Thank you, Professor Praveen. Thank you very much. Thank you.
Thank you very much. Thank you.
Thank you, sir, for your kind words and encouraging words. I wish to remind that another industry stalwart, Dr. K.R.S. Narayanan, is also with us from Reliance Industry. He's head business there. So, with your kind...
because you have spoken so many experts, so I'm really sorry if I could not basically speak their name in this, but really I am thankful to all. Thank you. Yeah, Praveen, continue.
Sir, it is my proud privilege to extend now vote of thanks at the end of this FDP. So I am grateful to Professor R.A. Gupta, sir, our Honorable Vice Chancellor, sir, to spare his time to grace us in the inauguration, as well as this function, as well as in the intermediate Art of Living program also. He came with us, and our the backbone of the program are experts who delivered extensive talks and discussed breadth and length about the recent research and their implementation strategies, the state of art. So I am grateful to Dr. K.R.S. Narayanan, Dr. S.B. Hegde, sir, Dr. Pateria, sir, Dr. Bhavna Tripathi today morning from Manipal University, Jaipur, Dr. Bhagat Singh from SRM Amravati nowadays, now CRI Dr. Guru Vittal from Chief Scientist there, and Dr. Sandeep Chaudhary ji, Professor at IIT Indore, Dr. KVA Subramaniam from IIT Hyderabad himself, and many researchers say Dr. Kevan from SPNIT Surat, and Art of Living team under Paras Kohli ji, Shreya Agrawal and his team. Then Dr. Vinod Kumar Daria ji from psychiatrist at Medical College Kota. Yesterday he had a wonderful session on stress management, sir. Most of the participants liked his and he was very practical in giving examples from ground roots level. He talked in examples from our गांव से, देश से, धरती से के एग्जांपल्स से कैसे हम अपने आप को रिलैक्स रखें, उन्होंने बहुत बताया. तो आई एम वेरी ग्रेटफुल टू ऑल द एक्सपर्ट्स and above all the participants who remained with us, glued with us for so long sessions, more than 4.5 hours, about 5 hours daily we interacted, and most of them were with us for whole more than 4 hours, more than 4.5 hours, whole days, whole 5 days. So it was a comprehensive FDP, sir, and I am grateful to all the participants for being with us, for selecting us for this FDP to join. And in today's chief guest, Professor A.P. Singh ji, sir, who had been invited on a very short notice on only day before yesterday, or yesterday only, we requested him and he kindly accepted our request. Sir, grateful to you, sir, for sparing your valuable time. And my own dean, Professor Anil K. Mathur, always encourages us, and the department and the university departments under his able guidance is nowadays doing very well, sir. So I am very grateful to Professor Anil K. Mathur, sir, and many whose name might not have been spoken, but they have helped in any direct manner or indirect manner. I am very grateful on my behalf as well as on behalf of Rajasthan Technical University family. I express my sincere gratitude to everybody, and end this valedictory program, if permitted by Honorable Vice Chancellor, sir. May I close this program, sir, here?
Yeah.
प्रवीण जी, मैं एक बात कहना चाह रहा था.
सर,
अभी परसों रिलायंस से कोई एक्सपर्ट ने एक्सपर्ट टॉक दिया था, नाम मेरे को याद नहीं आ रहा, प्रवीण जी बताएंगे.
KRS नारायण सर अभी जुड़े हुए भी हैं.
हाँ, अभी हमारे साथ जुड़े हुए हैं सर. हाँ, तो सर उन्होंने लेक्चर दिया था कि रोड कंस्ट्रक्शन में प्लास्टिक वेस्ट का कैसे यूज कर सकते हैं. तो प्रवीण जी उसी टाइम लेक्चर के खत्म होते ही मेरे पास आए थे और हमने काफी डिस्कशन किया कि हम हमारे कैंपस में कोई सैंपल एक रोड का पैच लेके उस पर, जैसे नारायण साहब ने बताया कि प्लास्टिक वेस्ट का कैसे यूज करते हैं, तो हम सर प्लान कर रहे हैं कि एक छोटा सा कोई रोड का टुकड़ा आरटीयू में लेके उस पर वो प्लास्टिक वेस्ट की टेक्नोलॉजी जो रिलायंस यूज कर रही है उसको कैसे यूज कर सकते हैं. तो हमने हमारे स्टेट ऑफिसर साकेत माथुर जी से भी बात की थी. तो हम कोशिश कर रहे हैं सर कि वो टेक्नोलॉजी जो वहाँ पे यूज कर रहे हैं उसको हमारे कैंपस में भी एक बार यूज करके और देखें कि कितना एडवांटेज होता है.
डेफिनेटली माथुर साहब, आपको करना चाहिए. और ये तो आपको मालूम ही है कि कोई भी अगर आपको सामान लेना है, कुछ भी लैब बनानी है, तो मनी का तो प्रॉब्लम अपने साथ है नहीं. और अभी तो मैं तो किसी भी फाइल को जो है बिना पढ़े साइन करता हूँ आजकल. हमारे प्रोफेसर्स लेके आते हैं तो मुझे मालूम है कि यू ऑल आर डूइंग गुड वर्क. तो आप तो बिल्कुल कोई भी सेंटर बनाए, और जितने भी सेंटर ऑफ एक्सीलेंस बने, क्योंकि यूनिवर्सिटी का काम सिर्फ यूजी स्टूडेंट को पढ़ाना नहीं होता है, हम लोगों को आगे का भी काम करना चाहिए. ये बहुत जरूरी है. ये हमारे मंत्री जी ने भी कहा था उस दिन. तो करिए आप.
कर रहे हैं सर, उस पर हम स्टेट ऑफिसर से और प्रवीण जी हम कांटेक्ट में है, इसका कोई सॉल्यूशन निकालते हैं इम्प्लीमेंटेशन का.
नारायणन साहब, आपकी मंजूरी है हमें आगे इस दिशा में काम करने की?
बिल्कुल सर.
तो हम
आपसे
जो
हाँ जी मैं फिलहाल हाँ जी सर, बिल्कुल कर सकते हैं, हम साथ में कर सकते हैं, क्योंकि इसमें कोई एक ही चैलेंज पड़ेगा इसमें। एंड वन रिक्वेस्ट ऑल्सो, एक चैलेंज है तो फिलहाल प्लास्टिक की चुनने में चैलेंज होगी, क्योंकि अक्सर क्या होता है कि बैड चॉइस ऑफ पॉलीमर्स और प्लास्टिक्स में खराब हो जाती है रोड, और टेक्नोलॉजी का भी खराब होती है उसका नाम। सो रिलायंस ने क्या किया है कि बीइंग द बिगेस्ट पेट्रोकेमिकल कंपनी, वी हैव आइडेंटिफाइड द बेस्ट पॉलीमर्स। सो जो कुछ भी है हमारे पास टेक्निकल डाटा, जो कुछ भी है, मटेरियल भी है, हम देने के लिए तैयार हैं, कभी भी तैयार है हम साथ में करने के लिए, क्योंकि इंडस्ट्री और इंस्टीट्यूशन साथ में काम करना है। अगर कोई टेक्नोलॉजी या एजुकेशन को आगे स्प्रेड करना हो तो फिलहाल इंडस्ट्री की जरूरत बहुत पड़ेगी सर। वॉट एवर टेक्नोलॉजीज हैव टू बी प्रैक्टिकली यूज्ड, डेमोन्स्ट्रेटेड एंड देन टेकन टू द कंट्री। जैसे आत्मनिर्भर भारत के लिए इंडस्ट्री की जरूरत है इंस्टीट्यूशन के साथ काम करने में। बहुत खुशी होगी सर मेरी।
इसमें मैं प्रोफेसर नारायण, वन मोर थिंग आई वांट टू ऐड एक्चुअली।
हाँ जी सर।
कि हमारा जो राजस्थान टेक्निकल यूनिवर्सिटी का जो सिविल डिपार्टमेंट है, बहुत रिच डिपार्टमेंट एक्चुअली, ऑल आर फ्रॉम गुड इंस्टीट्यूट्स, पीएचडी फ्रॉम वेरी गुड इंस्टीट्यूट्स। अगर आप चाहें तो अपनी एक जो है लेबोरेटरी हमारे यहाँ एस्टेब्लिश करें, आपका रिसोर्स होगा और हमारा ह्यूमन रिसोर्स होगा, फैकल्टी होगी, तो वी कैन डू टुगेदर गुड वर्क। एक एमओयू अगर हम बना लें और इस तरह से करें, तो इस तरह की भी एक लेबोरेटरी बनाई जा सकती है जहाँ पे आपका भी इनपुट हो, हमारा भी इनपुट हो। इस तरह से भी हम लोग कर सकते हैं।
वी कैन वर्क ऑन दैट सर, वी कैन वर्क ऑन, क्योंकि कंक्रीट में ज्यादा कुछ काम हो रही है अभी रिलायंस में। सो वी कैन वर्क विद सिविल इंजीनियरिंग डिपार्टमेंट फॉर कंक्रीट एज वेल एज वेस्ट प्लास्टिक्स इन बिटुमिन।
Definitely, sir. We will be in contact, and hopefully we will converse to some associationship, and we will be helpful to the society and region in that.
जरूर सर, जरूर डॉक्टर प्रवीण साहब, जरूर।
Thank you, sir. So with this positive note, if permitted, we can close this FDP, sir.
Yeah, definitely you can close now.
Thank you.
Yeah, thank you. Namaskar. Namaskar.
Namaskar.
Thank you.
Thank you all participants, and
Namaskar sir. Thank you.
As announced, I will send the quiz in about half an hour time, and will communicate you on the mail. But while going, our one practice is there. If everybody can put on his or her video, we may take some group photo. Kindly. Kind request to put on the videos if you may, please, and we may have some because virtual group photo is the only thing which we may take. Anyway, since it is convenient to many, and it may take some more time, but if convenient, yes, good. So most of you have been here, so I take this opportunity to thank everybody once again, and I find that many of the faces are from South, and many of the faces are from mid India as well. So thank you once again. Mathu sir, can we close, sir?
Yes. Thank you. Thank you, everybody.
Thank you, sir.
Thank you, sir. Thank you, Nayan, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you.
Namaskar.
So I close this FDP here. Thank you all, sir. Thank you very much.